All right, guys. So I guess we'll just start the session because if we just wait for any further, it's going to be very late to end the session. So yes, guys, thanks all for joining over here. And the main motto of this particular workshop is to how you can kickstart your career in machine learning and become job ready by the end of 2024. Okay. Now, one thing that I'll tell you right away is that we are not trying to sell anything to you. Okay, over here it's just I was just having this kind of an initiative that because I was not having any kind of work to do in Saturday evening, and that's why I just thought to arrange this particular session for all the students out there who really needs to start their career in the field of machine learning by the end of 2024. I'm going to share at the end of this whole workshop a proper roadmap, as in how you can start your journey from extreme zero, and with what kind of tools and technologies you can become a job ready candidate by 2024. Okay. And yes, because I'd also shared one form with you guys on the community, that is how if you would be interested to know more about the training programs at Spartificial. So because a lot of you, I should say 100% of you guys have mentioned that you would like to know more about what kind of things we provide at Spartificial. So I'll also mention about that at the end. All right. So these are the main topics that we are going to cover. But before that, for the people who are not really aware about me, I am Rohan. I am currently working at Spartificial as the lead program manager. Okay. So my main motto over here in this workshop is to let all of you know about this particular things. To start with, okay, the first few hours of this workshop is going to be completely with respect to understanding machine learning. Okay, you're going to understand a lot of different components in the machine learning. After once we are done with respect to understanding, okay, what is machine learning, I'm going to help you learn one algorithm that is called as linear regression. Okay, linear regression is simple yet very powerful model in machine learning that's going to help you clear a lot of concepts when it comes to machine learning. Okay, if you know just how linear regression works, how the inner side of the linear regression works. Okay, not overall. Okay, you are not going to go ahead and use some kind of online tools available to get your things done. I'm going to help you understand how each and every step you can take in order to build your own simple machine learning model. And you don't really need to know any kind of Python for that. I am having one of the code along session notebook that is ready over here that I'll be sharing with you once we are about to start the coding part. Okay, so anyone over here who is not even good with Python, you can try to just watch what I'm doing. And for the students who are really good with Python, or at least know what is Python, you have done some of the projects in Python, then you can also code along with me. Okay, but it's not at all compulsory for any one of you to code along with me, especially if you're a beginner. I would recommend that you simply watch what I'm doing. Okay, but that will be the second part in this workshop. After this, I'll be sharing you, as I had mentioned, the whole roadmap that you should follow, how you can start learning extreme basics of everything you need to know in machine learning, and then how step by step you can go till the level of specializing in any of the field of machine learning. Okay, let it be computer vision, natural language processing, could be anything, even data science for that matter. Okay? So the whole roadmap I'll be sharing you after that coding part is done. Because see, the reason I included the coding session over here is to give you a better experience of how machine learning works. Because majority of the models that you will see in the field of deep learning, right, and all of this machine learning, NLP, computer vision, majority of this kind of what do you call this, models are working on the same type of principles. So if you understand just one model over here, that is linear regression, transitioning into different type of machine learning algorithms, even in deep learning algorithms, is going to be simple for you. Okay, so that's my main motto over here. That's the main thing. And the last part is the training programs at Spartificial. And this is just because all of you, 100% of you guys were interested in to know about how you can have this kind of fusion of two things, that is AI and astronomy. Okay, so that's something that I'll be telling you at the end of the session, and what all kind of things you can create, if you are enrolling at any of the programs at Spartificial. Okay, guys. So again, one thing, guys, it's only for the students over here who are fresher in machine learning, or someone who is trying to look into what should be the roadmap that I need to follow in order to become job ready by the end of 2024. I'm not saying that this workshop is going to help you be job ready, but this workshop is going to help you understand what is machine learning, what is the beauty of machine learning, okay, with respect to the coding part as well. So once that is done, and if you are really interested to work in this kind of field, if you are someone who is really charged up by the end of the coding session that yes, I want to work in this kind of field, okay, then I'm going to share a roadmap with you that okay, this is how you can start learning this kind of tools and all the kind of resources that you need to know in order to get started with it. It's not going to cost you a single rupee over there. All the resources over here are highly reputable, at the same time completely free of cost. Okay, so you must have seen a lot of videos and blogs out there on internet, right? But I'm going to share you a proper way that okay, step by step I'm giving you a roadmap, but along with that, from where exactly you can learn all these kind of things for free, everything I'll be sharing with you all. Okay, and yeah, at the end I'll be just talking about the programs that's Spartificial. Just a second guys, I'll just figure out something. Okay, yeah, great. And let's, if you are willing to communicate with me, if you want to ask any kind of doubts to me, you can feel free to like, raise your hand and I'll take your doubts over here. And just because we are having very limited amount of students over here, it's going to be very simple for me to address each and every one of you. All right. And if by chance anyone over here is already from the ADS batch that I'm currently taking at Spartificial, okay, because I can see there are some of the people over here from the ADS batch. So, you can use this particular workshop as like part of a revision and something that we'll be seeing in upcoming few lectures in your training program itself. All right guys, so let's just get started. Just one thing, that anytime if you feel like it's getting overwhelmed, it's overwhelming for you, it's completely fine. Okay, especially if you're completely new to the world of machine learning and Python, my main motto over here would be to make it as simple as possible. Okay, I'll be trying my best for that. And just one way to spend this Saturday evening with all of you. All right, that's the main motto. All right, guys, so let's get into it. I'm not really sure if you're able to type anything in the chat currently. Okay, guys, can you just go ahead and type something in the chat if you're able to, or else I'll do some kind of changes in the settings.
Chat isn't available, sir.
Okay, just a second. Can you try it now? Is it available now? Okay, perfect, guys. Perfect. Great. Great. Perfect. 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 All right, guys. Over here, please, one more request from my side, because I'm having very limited amount of students over here. I just hope that you don't just randomly unmute yourself and share some random stuff over here. Okay, let's just be very specific to what we are doing over here, and that would be pretty much helpful. And if I'm finding any one of you is just spamming and doing nonsense stuff, I'll just simply remove you from this particular meeting. All right, guys. So yeah, just make sure that everyone is enjoying what I'm giving over here. And if you're having any kind of doubts in between, you can share it with me. So to begin with, guys, let's try to understand the whole concept of artificial intelligence, machine learning, and deep learning. So I would like to ask you one question over here, that would you like to tell me what are some of the AI tools that you must have used recently, especially in 2023? What are this kind of AI tools that you've been using? It could be anything. You can type it in the chat. You can unmute yourself. It's your choice. What are the kind of tools that you have used that has automated your work, made your life very easy? What kind of things like this you have used? Chat GPT is there, Mid Journey is there. Any other examples of AI tools that you must have heard about, if not used? Bard, Chat GPT, Siri. All right. Copilot. Yes, that's great. So clearly I can see a lot of answers are with respect to the Chat GPT. Yes. Now this is something that has boomed since 2023. I should say the end of 2022, right? And there are a lot of things that you can do currently with the help of ChatGPT, right? And same goes with Bard and Gemini that has been introduced recently, right? So currently what I'm trying to share with you all is that what are some kind of tools that you can make if you are aware about this kind of technologies. Now, will you be able to create all the kind of examples that I'll be sharing you over here? The answer clearly is no. It depends on what kind of specialization you are going to work with. And with respect to that kind of specialization, you can surely be able to be a part with you can basically be a part of a team which works with this kind of in building this kind of products. Okay, that's something that you can surely do. Creating this kind of uh, thing by yourself will be pretty much difficult, right? So yeah, you will be working with a part of a team which is specializing into some kind of a product, and in that particular product you will be working as some kind of part in that particular product, right? So first example that we are seeing over here is indeed chat gpt, right? I knew that a lot of you will be mentioning about the chat gpt, and that's why I'm having it at the top. So ChatGPT is coming into the league of generative AI, where we talk about large language models. Okay. So these large language models are just how you are able to make your machines understand your language. Okay. That is human language. And therefore it falls into the category of NLP. NLP stands for natural language processing. So let's say if you're specializing in the domain of NLP, and especially in the NLP that is called as LLM. This LLM is basically going to help you ensure that you are creating some kind of product that's similar to what ChatGPT is. Okay, that's one of the examples that we are having. Now, another example, if I'm showing you over here, is the Netflix. So this is a prime example how a recommendation system works. Okay, so in this recommendation system, you need to know one technology in machine learning that is called as unsupervised learning. Okay, so unsupervised learning is something that I'm again going to explain in a proper way. But yeah, unsupervised learning, if you're aware about it, and there are some of the machine learning algorithms that you know about it, and you will be able to create this kind of a recommendation system. So what it primarily does is that whatever kind of screen time that you or I am having at Netflix, they're just trying to increase that their screen time, basically, right? That's the main job of having this kind of a recommendation system. If I'm talking about, let's say, YouTube or Netflix, if I'm talking about, let's say, a shopping platform like Amazon or whatever kind of shopping platform that you might use, over there again there is a principles of recommendation systems, but their logic would be to make you give some kind of recommendations, basically, through which you can purchase a lot of different things at the same time, even though you will not have planned about it, but still because they are recommending, and if it's within your budget, you will surely go ahead and purchase it, even if you haven't planned about it. So this is how basically recommendation system works. Okay, and there are a lot of ways through which you can actually create this kind of recommendation systems. One of which you can see that a lot of people are using is clustering. But is clustering the only one thing that is being used? The clear answer is no. Okay, there are a lot of different technologies that are coming together to create this kind of a recommendation system. Okay, clustering is just one of the way through which you can achieve it. Okay, yes. Now coming to the third example over here is, let me just change this. Yeah, is the spam detection model. Okay, so again, this spam detection model is falling into the category of natural language processing. Can anyone tell me why is it again falling into the category of natural language processing? Is anyone aware about it? And it's completely fine to give me wrong answers. Okay, guys, first of all, just be very comfortable. This is not something like, this kind of workshop that I have created over here is not at all to you will be getting judged or anything like that. It's completely fine to have wrong answers. If you are just having this kind of an idea that, okay, yeah, whatever is the question, I am able to think in a proper way, it might be incorrect. So don't have any kind of fear of answering the questions that I'm asking over here incorrectly. Okay, so is anyone over here having some kind of ideas that why is this again falling into the category of NLP? You can maybe unmute yourself, you can type it in the chat. It's completely your choice, guys. Behavior of source. Can you elaborate more with respect to this, Aditya? Behavior of source. Anyone else can also try. Just like ChatGPT. ChatGPT, again, I have told you that it's a prime example of natural language processing. So how can a spam detection model be also a part of NLP? So it's a process that connects the process the contents of the emails to figure out if it is misleading. This is absolutely correct, right? So this is the main principles of how spam detection works. But why is it a natural language thing, language processing task? Because again, whatever kind of text you will be getting as a part of your email, let's say it is in any kind of language. Okay, it could be any kind of language. Now, just because let's say if it's not relevant to what type of work you basically do, okay, or any kind of thing that is just going to be a real spam for you, what's going to happen? This kind of machine learning tool that is there in your email applications is going to read each and every keyword that is present in your text, that is in your emails. And if they are able to find out certain kind of keywords that's completely like, as Yuvraj just mentioned, misleading, or maybe it's not relevant to you, it's going to go into the spam detection folder. I mean, basically spam folder, right? This is one very good example of like, you must have seen this, but you might not be aware that there is a machine learning going on over here. Whenever you're getting some kind of text, it might be sometimes that like, if your email is really very important, but still this machine learning model is detecting it as a like, spam. So at times you must have gone through this kind of like, process that you might have, let's say for example, registered for this kind of workshop, and you got the link of joining this workshop as a part of the spam, even though you have paid for this kind of workshop. I'm just giving an example. Okay, let's say if you have paid a very high amount for this workshop, but still it went into the spams. This kind of things also happens. Okay, this also happens. But yes, most of the times the job of this kind of spam detection models is to identify that what is that something that might be not relevant to the customer. Just send everything with respect to that into the spam folder. So yes, because again, machine needs to understand the text sent by some different person. That's why it is falling into the category of NLP. All right. Now coming on to the next example is computer vision. Okay, so in this computer vision, it's completely new field that I've talked about. So let me just mention it into the chat. Just a second. Yes, so this is called as computer vision. So in computer vision, what happens? Just like in natural language processing, you are trying to decode the text and give some kind of meaning to it to the computers, right? Or to the machines. Just like that, if you want your machines to visualize something and make some kind of decisions on top of that. So this is where we talk about computer vision. So one of the examples that you're seeing currently is that you're having some kind of a scan of your body, and then your model is able to exactly predict that what part of this whole image is having some kind of a problem. Let's say for example tumor, because that's some example that I've shown on the screen currently. It could be literally anything, right? So if you have to detect this kind of tumors by yourself, that means as a human, if you have to detect this kind of thing, you should spend a lot of time to like highly accurately predict that, okay, yeah, this is where like on this part of the uh, brain or whatever kind of organ you might be working on, that this is exactly where the problem might be there. Now let's say if you're going to treat this kind of tumor with the help of X-ray, okay, or maybe any kind of dosage you would like to like give to the tumor to break it, right? So let's say that you are trying to give X-rays to this specific part, but what if there is some kind of mismatch over here? If we are going to give the X-ray dose to the part of the organ which is completely fine, it's going to be problematic, right? And therefore having this kind of accurate models is really one of the challenging things that you will see in the field of medical domain, right? And the example that you're seeing is called as image segmentation. Okay, you are trying to take different pixels or different parts of the image and give some color to it, and this color is going to represent something. For example, this yellow part is showing you that it's an advancing tumor, right? This red part is telling you it's a necrotic tumor core, the core of the tumor basically. So all of this kind of things is falling into the category of image segmentation, right guys? So yes, as I mentioned, this is the example of computer vision. All these examples that I've told you guys, all these examples that I've mentioned is telling you that some different kind of specialization is being used over here to get this kind of products ready into the market. Okay, so for people like us who are able to use this kind of chat GPT to ask any kind of questions and get some kind of solutions, you might have again seen that like chat GPT is giving you wrong answers. So how many of you have experienced this, that you're asking something to ChatGPT and you are getting some kind of wrong answers? Have you ever experienced this? Any one of you over here? Yeah. So that's one of the problem that we face with ChatGPT, right? Because it's still in the learning phase, right? It's still in the learning phase. It's not yet the best model that's available, but it's still good enough to answer a lot of your questions with a decent amount of accuracy, right? And still it's helping a lot of people. And because of tools like this that are available currently, you are also seeing huge layoffs going out even in the best type of companies that you've heard about. Recently Google laid off a lot of employees, right? Hundreds of their employees they laid off. But yes, that's something that you need to keep in mind, that yeah, all of these kind of models that you're working, depending on what kind of task you are doing, there might be different kind of preference that you might give to it. For example, some of this kind of models does not require high kind of accuracy. It needs some different type of things. Okay, all of these things are called matrix, how you evaluate your model. Okay, so I won't be going much into the depth of this, but yeah, this is something that you need to know, that there are different ways evaluating that how you can say that your machine learning model is performing so well or so bad or mediocre, whatever it is, right? So yeah, this is about, like, what are some different examples with respect to, like, machine learning. These are the type of things that you can start working on. And, like, students at Spartificial, I'm just giving you an example, are working on all this kind of things as a part of their internship. Okay, I mentioned about the training programs, right, at Spartificial. After the training program, there is always an internship that is, like, free of cost, that we give to all the students to implement what they have learned as a part of their training, and even grow their skills more on top of what they are having currently at the end of the training program. So yeah, these are the type of things that students are working on. Okay, and just get your skill sets enhanced as compared to what you might have currently at the end of the training program. But yes, enough skills with respect to machine learning, right? So first of all, I've talked about some different type of examples, right? Now I'm going to actually dive and explain you what is the main difference between artificial intelligence, machine learning, and deep learning. But before I move on to this section, are you having any kind of doubts, guys? Are you able to understand this? Yes. What about others, guys? Are you able to understand this? Great. Great. Fantastic. All right, so now let's talk about what are the main differences that you should know about when we talk about artificial intelligence, machine learning, deep learning, and where is data science falling into all of these kind of categories, right? So let me just talk first of all about artificial intelligence. So just think of it like a universe. Okay, everything is, like, filled within itself, like within the universe itself. So that universe is nothing but artificial intelligence. So what is the main job of artificial intelligence? To give some kind of ability to the machines. Okay, to give some ability to, let's say, you can also call it as a non-living thing. Okay, whatever is non-living, if you are giving any kind of ability to that to perform the task that humans can perform, all this kind of techniques that you will be implementing is falling into the category of artificial intelligence. Okay, so this artificial intelligence is a whole huge universe. Okay, now inside this universe you might have some different type of galaxies, stars, and whatnot, right? So within this artificial intelligence you are having many subcategories, like machine learning and deep learning. So let me first of all give you the idea with respect to what is machine learning. Okay, so as I've mentioned, the prime goal of the AI is to make a non-living type of stuff, especially machines, give ability to make some decisions like what humans do, right? So machine learning is one of the way through which you activate this kind of, like, senses in this non-living things. Okay, now there are a lot of algorithms that are out there, and probably I've got a lot of questions, like, once you start doing machine learning, you will see that there are a lot of kind of algorithms that you need to know in order to implement them in different kind of scenarios. But what is important for you is that you are aware about that what type of algorithm is to be used on what type of scenarios. If you are aware about this, you are already far better as compared to, like, what a lot of people who are not really aware about, like, when to use this kind of models Okay, you will be far better than this kind of dudes. Okay, you just need to know that, okay, yeah, these are the best type of machine learning algorithms for certain kind of problems. So if I'm solving a specific problem, which algorithm should I use? Okay, so whenever you are working with the algorithms, okay, to basically automate some kind of stuff, is what we call as machine learning. And just like machine learning, there is one certain type of algorithm which we called as deep learning, where we try to mimic how a human brain works. Okay, so basically however our human brains are working, right, with the help of neurons, we are having some different connections of neurons, which is like, which is making me say all of these things to you guys right now, which is making you guys understand what I'm saying right now, right? So just like this, there is a connection between all the neurons in our brain. We are trying to mimic that same exact thing when we talk about deep learning. Deep learning is a special type of framework you can consider, or special type of algorithm, which is going to work like how your brain does. Okay, and that's why we understand a lot of things within the deep learning that we call as artificial neural networks. Okay, artificial neural networks, again one special type of algorithm in which again you are having a lot of different kind of branches. A lot of different kind of branches are found within deep learning itself. Okay, but the prime thing that you do with the deep learning is that you basically go ahead, create this kind of architectures like how human brain works for different kind of functions. Okay, and if you are doing it with the help of neural networks, you call it as a deep learning. All right, so this is the main difference between AI, ML and DL. AI is this whole universe that I've talked about, where machine learning and deep learning is falling into that particular universe, through which you are enabling this kind of non-living things or machines. Uh, you are enabling them to do the tasks that humans usually do and make your life easier, right? So that's what AI is. But then ML and DL is some of the tools through which you can make this kind of softwares or product or whatever it is, right? So that's the main idea with respect to AI, ML, and DL. Now you must be thinking about what is data science over here. So in data science, there are two key components. Okay, I have not really mentioned about the data science over here, but just because I've talked about it in this workshop, let me just go ahead and talk about data science for a second. Okay, so in data science, what really happens is there are two main things. One is to do some kind of data analysis from the current data. For example, let's say if you are having your own, if you are like, if you're having this kind of a record of maintaining your finances, that per month where you are spending your money in what kind of regions. Let's say you are having this kind of data for yourself. Okay, and let's say that you are a data scientist. So what kind of things you can do with this kind of data? Let me just give you that kind of example. Okay, so with the help of the skills of data analysis, first of all, you try to understand that where you are trying to spend your money, where you should not really be spending your money to. Okay, this kind of analysis, this kind of observations is going to help you improve your finances. And if you're able to, like, follow this kind of analysis that you have done, what's going to happen in the upcoming few months? You will surely see that your whatever kind of financial goals that you want to achieve becomes very easy to achieve. I have personally implemented this in my life, and my life, trust me guys, has literally changed from that point. Okay, the moment I have started incorporating this part of machine learning into my real life, especially when it comes to these finances, I am able to manage all of it very well. Okay, so this is the power of data analysis. You are trying to analyze something and make some kind of decisions based on that. But on top of that, you are also adding the skills of machine learning, not just data analysis, but also the machine learning. Let's say if you want to predict something in future, let's say that today, if I am going to make any kind of changes in my routine in terms of finances, after few months, how is it going to impact my finances? If I want to make this kind of predictions, I need to have this kind of machine learning system that is incorporated into it. Okay, that's something that I need to know, that okay, because I am making this kind of changes in my particular finances, I'll simply be going ahead, apply this kind of machine learning strategies to identify that by this change, if I do now, how will it impact my finances after, let's say, 3 months, for example. So this is the job of data scientist. They have the data. From that data, they make some kind of observations, their analysis, and on top of that analysis, they are going to go ahead and make some predictions in the future with the help of machine learning tools. That together is a data science. Okay, data science basically allows you to take some kind of decisions very easily, and you can rely on that particular predictions that your machine is basically giving. Okay, so yeah, that's what a data science is, guys. So any kind of doubt so far in understanding the difference between AI, ML, and DL? Would you like to ask any kind of doubts over here? Are you guys able to what is the difference between AI, ML, and DL, and also what is data science? Yes. What about others, guys? What about others? What about everyone? Anand, Ruchika, Elizabeth, Krish, and I cannot really see all the other members. You are able to understand, right? That's great. Great. Because see, I don't really want to spend my Saturday evening by just saying these things to myself, because I'm aware about all these things, right? I want all of you to, like, actively take participation of something that I'm mentioning over here. And please feel free to ask any kind of doubts. It could be as incorrect it might sound, but it's completely fine. Over here, you are to learn something, right? Learn something useful for yourself. I think there is something in the chat. Sir, it means we can also use it. We can also use AI for portfolio management. You can use AI for whatever you think, Raj, whatever you can think of, just in order to remove the possibilities of errors a human can make, and integrate some kind of AI system within that kind of whatever it could be. Let's say portfolio management, whatever it could be. Okay, it's going to help you, but for that you need to make sure that your machine learning model is highly accurate. Okay, if it's not accurate, it's going to give you some false predictions which will lead you to get some kind of outcomes which you don't really want for yourself. So keeping that in mind, and that's why this kind of tools, the roadmap that I'm going to share with you at the end of this particular workshop, is going to help you that how with different kind of tools you're going to ensure that you are creating this kind of systems by yourself. Okay, so yes guys, that's about what we are going to do in this workshop itself. I hope that answers your question, Raj. All right, how AI can be applied to art. One of this question that you have seen over here, uh, like that I'm usually getting with respect to art, I just like to tell one thing over here, is that have you think about giving some kind of a text to your model and it converts into a beautiful whatever kind of art it could be. Okay, let's say it could be a poetry, it could be some kind of a portrait, it could be some kind of digital painting, whatever it could be, right? Yes, one of the famous example is Mid Journey and Delhi, right? If you've not heard about Delhi Explorers and Mid Journey, then these are the prime examples through which, like, you can create this kind of artistic looking images. Okay, that's one of the example in the art. You can also create poems. Okay, with the help of Chat GPT itself, you go to Chat GPT and simply mention about this thing that, like, let's say whatever it could be. Let's say you are passing some of the paragraph. Okay, you are having some of the paragraph. Let's say for machine learning only, you are reading some kind of text and you are ending up on some of the paragraph that is really very hard for you to understand, or just for a, like, trial purpose, take any kind of paragraph from the internet, copy that part, give as a prompt to your Chat GPT and ask it to convert it into a poem and explain it in a way that, like, an artist would easily understand it, and you will see that how beautiful it's going to create a poem for you, and it's going to help you understand it. Okay, you can also ask this kind of tools like Chat GPT or Google Bard to follow certain kind of norms. For example, like, you can choose any of your favorite poet for that matter. Okay, and ask your AI tool to give this kind of poem in their own characteristics of how this kind of poets are using in their, like, in their whatever writings that they publish. Then you will see that in the same format you will be getting the output. So these are the prime examples of, like, how you can integrate the AI system and you can implement it to your artistic side of part. All right, guys. Now, as I'd mentioned, now we are going into one of the part of this workshop where I am going to I'm going to introduce you to three different branches of machine learning. Okay, deep learning, NLP, like computer vision, all this kind of things that we have discussed are going to fall into this specific slide somewhere or the other. Okay, that's that's going to be it. This is the main thing that you should know about. Okay, so in the center again we are having the machine learning. Now there are three subcategories into the machine learning. One I had already talked about, that is unsupervised learning. And in this unsupervised learning, there is a recommendation system that I was talking about, right? That's one of the example. But yeah, that's just one example that we are having. You can do a lot more things. You can see a lot of different kind of examples that I've mentioned in this specific slide, right? So if I talk about, let's say, supervised learning, okay, in terms of astronomy only, if I just talk about it, supervised learning is something that you will highly see, and not just in astronomy, for that matter, in any kind of domain. Okay, in any kind of domain, as a fresher you will be expected to know a lot more about supervised learning as compared to the other two, that is unsupervised learning and the reinforcement learning. So what happens inside the supervised learning, there are two main categories, that is classification and the regression. One is classification and the other one is regression. In classification, you can do a lot of different type of classifications. Two of the famous examples I'll be giving you is image classification, where let's say if you're having a simple straightforward problem statement, you're going to create a AI system that's going to classify some different type of objects that's there in the data set. Let's say it's simply to classify between a cat and a dog. Okay, so you're going to train your machine learning model. You're going to train your machine learning model in order to classify if whatever is the image that we are passing it as an input is able to identify it correctly as a dog and correctly as a cat whenever there is a cat. So this kind of problem statement falls into the category of classification. Now, if I talk about some different type of classification problem, it could be identity fraud detection. So what does this mean? In this identity fraud detection, you're trying to fake your identity, and you're trying to portray yourself as someone else. So if I am having this kind of identity fraud detection installed into my system, I'm going to identify if anyone ever is going to make this attempt of falsely telling that he is someone else or she is someone else. So that kind of thing you can again achieve with the help of classification. Just like this, you can also do, let's say for example, text classification based on certain kind of text you are receiving. Is it a spam or it's not a spam? Again, this falls into the category of classification. So these are the prime examples that you should be aware about when it comes to the classification. Okay. And then the other part of the supervised learning is regression problems. In regression problems, the one example that I gave about my personal finance is falling into the category of regression. Okay. Regression basically helps you predict a specific value. So we just go to the next slide over here. You can see that this is the example of regression on the right hand side. Okay. Where if I give this kind of inputs to my model, it's going to predict some kind of value. It could be any kind of value. So this kind of projects are basically called as regression. Okay. So coming back to the slide. And typically, as I have already shown one example with respect to the weather forecasting, that's one of the example. The other reason, the other kind of examples over here might be like, how you can handle your finances in the upcoming future. If you want to identify that, okay, if I'm managing my finances in this specific ways, after 3 months, what will be my goal that I'll be able to achieve in the financial domain? So I'll be getting certain value, and that value is continuous. It's not discrete, either 0, 1, 2 like that. It's continuous, could be any value. So this kind of problem statements are falling into the category of regression. Now, being a starter, you should have at least solved one problem statement in each of the domain that you are seeing over here. It could be as basic it might be, but at least one project from each and everything that I am talking about over here. Currently, I've just talked about the supervised learning and only two examples over here. Let's say if you want to specialize yourself into the supervised learning, then you should solve more projects with respect to the supervised learning. Okay, I'll be talking about what are the kind of ways you can follow through which you can obtain an amazing this kind of portfolio for yourself, how you can create amazing portfolio for yourself with all this kind of projects, and how you can approach anyone with this portfolio. The chances would be that you will be 100%, not 100%, but high chance will be there that you will be getting hired. Okay, but I'll be talking about all these kind of things at the end of the session. But yes, these are the examples, these are the main tasks you will be focusing on in the supervised learning: classification and regression. One important part is that in the supervised learning, you are always going to have this kind of target column, where this target is nothing but your model will always be exposed to some kind of data which we already know that, if these are the inputs, this is going to be your output. If this is your input, this is going to be your output. This kind of inputs outputs your model will already be aware about, and that's why we call it as a supervised machine learning, where you are going to supervise this machine learning with the help of this target column, where this target column is nothing but on the set of some inputs, you are having some kind of outputs that your model is already aware about. Okay, and based on that training, it will start to predict something that is not even shown to your model. And that's how basically supervised machine learning works. The second type of machine learning algorithms that we have is falling into the category of unsupervised learning. So what happens in the unsupervised learning? Over here, you don't have any kind of data that is shown to the model. It is able to make any kind of analysis by itself based on the pattern that is being formed in your data, which is very impossible for us to see with the help of our eyes. But thanks to this unsupervised machine learning algorithms, it will be able to decode even difficult patterns that it's very hard for us, or it will be impossible for us to decode if we have to do it, or it will take a lot of time for us to get to that point. So this unsupervised machine learning algorithms don't require any kind of outputs. It will able to give you some kind of output, some kind of prediction, some kind of patterns that are there in your data by itself. It doesn't need any kind of supervision, and that's why we call it as an unsupervised machine learning. The two prime examples of the unsupervised machine learning is clustering and the dimensionality reduction. Okay, clustering and the dimensionality reduction. So what happens over here in both of them? There are more branches in the unsupervised learning. For example, let's say association is one of the other branch that you have in unsupervised learning, but just giving you some of the details so that it's not getting overwhelming for you guys. Okay, so in this unsupervised learning, you are going to have dimensionality reduction. What does that mean? Let's say if you're having a huge data with a lot of input features, and now if you want to visualize it in a proper way, how will you do it? If that's having huge data, okay, typically visualizing the data, we are able to visualize anything that is within 3 dimensions, right? But what if you are having more than 3 dimensions? How do you convert this data into this kind of either 1, 2, or 3 dimensions that you will be able to make sense out of it? So that's where we use dimensionality reduction kind of concept that falls under unsupervised machine learning. Just like this, we are having another type of example called as clustering. And because I already mentioned about we use clustering when we talk about recommendation systems. So yeah, that's where you can apply the one of the examples in the clustering is recommendation systems basically. All right. And how you can also segment your customers. This clustering technique can help you save a lot as a company to spend on marketing. Okay, whatever kind of product you might be selling, if you want to do any kind of marketing with the help of this clustering techniques, you will be able to segment your customers in a way that which amongst all of this crores of customers that you are having, whom you should be sending any kind of SMS, any kind of calls, whatever it could be, whom you should be spending any kind of money, whom which are mostly aware about, that they will be getting converted into some kind of sales. Okay, basically they are going to purchase something from you. Okay, so if you are able to target out of crores only, let's say 1 lakh people who are for sure going to buy something from you, if you're going to make this kind of attempts, so it's going to be very beneficial for your company, right? So yeah, that's where the clustering algorithms in the unsupervised learning are used a lot. Okay, and the last one that you are having in the machine learning is the reinforcement learning. This reinforcement learning is probably, like, one of my favorite. Okay, because what happens over here is you don't require any kind of data, you don't require any kind of target. In supervised learning, you were needing a data along with a target column. In unsupervised learning, you don't need any kind of target column, you just need a data. Okay, and machines will be able to figure out something from it automatically. But when it comes to the reinforcement learning, you don't need any kind of data, you don't need any kind of target column. You just need two things. Okay, you just need two things. One is your agent, and the second thing is environment. And that environment, like that agent should be getting very used to that particular environment. That's the whole job of reinforcement learning. It's highly used when we talk about gaming. Okay, you might have heard about chessboard or any kind of games you may play. Let it be Call of Duty, Counter Strike. You must have seen this kind of bots. And currently, you will be seeing that there is an option of AI bot. So, what is that AI bot? That these are the kind of bots that are trained with the help of reinforcement learning. These bots are your agent. The game that you are playing becomes your environment. So, how easily your agent will get used to the environment. If I'm talking about any kind of games, how easily your bot of the game gets used to the game is the whole purpose of reinforcement learning. It does a lot of trial and errors in the training process and works on a reward system through which it basically improves itself. Okay, so that's about reinforcement learning. I won't be talking much about the reinforcement learning because this is the last kind of stage you will be touching. Once you start with the supervised learning, then you must go to the unsupervised learning. Then from the unsupervised learning, you should come on to the reinforcement learning. This is how you should progress. That's a typical way through which you will be able to access each and every component very smoothly. Okay, you won't ever find any kind of difficulties. Okay, so yeah, that's how you should follow. And currently, what we are going to do in the code along session, I'm going to give you a problem with respect to regression. Okay, we are going to do a regression problem together. I'm just about to start with one of the algorithm. Okay, that is linear regression. But yes, guys, this is with respect to some different subcategories that are available, and everything, every product that you will be building will be falling in one or the other regions that I've explained over here. Right? So the main part over here is to understand what is supervised learning. If you are able to capture the concepts of supervised learning, it's more than enough, because yeah, we'll be building on top of supervised learning in this particular workshop. All right, guys. So yes, guys, any kind of doubts over here in understanding anything, or if you want to ask any kind of questions, you can go ahead. I'm giving you 2 minutes of time. You can ask me any kind of questions if you're having over here. Yes, we'll be uploading this session on YouTube, Jatin. If you are over here, we'll be uploading this session onto YouTube, and every materials that I'm showing you over here, I'll be, like, sharing this materials in the description of that video itself. So yeah, that's something that I'll be doing. Okay. All right, guys. So I'm assuming there are no doubts over here because I cannot see any kind of questions in the chat apart from that. Okay, great. So now we are about to start the linear regression part. But before that, I'm having one simple question for you guys, is to tell me that, let's say that the first image is A, the second image is B, and the third image is C. So out of this A, B, and C, which one belongs to the supervised algorithm? Okay, which one belongs to the supervised machine learning algorithm? A, B, or C? Type it in the chat. Let me see how much you are able to understand. A, B, or C, which one out of them is going to be falling into the category of supervised machine learning? You can try to at least guess it if you're not really aware about it. Yes, A. A is Krish. That's a bit incorrect. Raj and Krish, that's a bit incorrect. It's going to be C. Okay, A is this, B is this, and this is C. So because you are trying to supervise your machine learning algorithm, you need someone to teach the model in a proper way. And that's why the C category, that is the C option, going to be part of supervised machine learning, where you are having some kind of supervision during the training process. Then the second type of option that we are having is the unsupervised. So because we are left with only two options, A and B, so unsupervised fall into which domain? A or B? Think about it, guys. A or B? Unsupervised will be falling into which of the category, A or B? A. Okay. There is one answer in the chat. That is okay. Yeah. Okay. Great. A is the correct answer. Again, guys, I would like to mention this one thing. This kind of workshop is just for chilling out, okay, and trying to learn something. So don't be afraid of giving any kind of wrong answers. For example, right now, Krish and Raj tried to attempt one of the question, but they told it incorrectly, right? So it's completely fine. I gave the answer, right? That why it is not correct. So just like this, don't be ever afraid. At least with me, okay. Right now, I am with you guys. I'm over here just to spend my some time and give some kind of knowledge. That's it. So feel free to at least attempt the questions, okay? All right, guys. So yeah, that's correct. And because now we are left with only one option, that is reinforcement. So yeah, that's the robot that you're having in the middle. That's going to be with respect to the reinforcement learning. Okay. The reason why we are calling this first option A as the unsupervised learning, because it is able to get the idea by itself by reading at the data. This newspaper or magazine or whatever it is that it's reading, it's trying to make some kind of pattern that is present in that kind of data and give some kind of observations at the end of the training process or whatever is the process in the unsupervised learning, right? And lastly, this is going to be the reinforcement learning, because yeah, it's trying to it's a robot, it's nothing but an agent which is going to basically get used to any kind of environment. Let's say robot navigation, you are having some kind of a path that your robots need to understand. Robot could be any kind of a, let's say, a car, right? A toy car, which needs to understand the path by itself, how to navigate. So yeah, that's the reason why this falls into the reinforcement learning category. All right. Yes, guys. Now we are about to start with the supervised learning. Okay. And the algorithm that I'm going to talk about is the linear regression. And because I've already explained you the difference between the classification and regression, I'm going to talk more about, like, regression problem now. So what we are going to have is, I'm just going to stop my screen share over here and I'm going to write something on the board. And I hope that you guys are going to understand more with respect to that, because I'm sure I'm not someone who likes to share PPT and explain something, even though I've created the whole PPT. But yeah, I'll try to explain something by drawing something on my board and make you understand, okay, with respect to that. Right now, we're going to learn more about linear regression. Okay, we're going to learn about linear regression. But actually, you know what? I'll just give you quick 2 minutes of break. After 2 minutes, you can come back and we shall start with the linear regression part. Okay, guys? After 2 minutes, I'll automatically start. Currently, you can take this time to ask me any kind of questions you might have or anything that you would like to ask. Okay. But yeah, currently you can take a break of 2-3 minutes. I'll be starting right at 7:58. Okay. I'll be starting at 7:58. Till that time, whatever kind of doubts you want to ask, whatever it is, feel free to ask. Or else you can simply enjoy, take this time to relax your brain, because now you are going to understand something that's going to give you the essence of machine learning, how you can create your own algorithm. That's probably going to help you understand that if this is something that you really want to do in your life. Because I've trained a lot of, like, students in my past life, and it's like, once they understand these things, they understand that, okay, how much amount of coding is required, how much amount of mathematics is required, or what are the different kind of tools, what is the amount of aptitude that you should have to work in this kind of field. Obviously, I won't be able to explain a lot of different things, but yeah, for sure, I'll be making you aware about what is the center part of this whole machine learning that you should know in order to start making progress in this field from nothing to everything by the end of 2024. All right, guys. So yes, I'll be starting exactly at 7:58. By that time, you can just take your break. And yes, by the way, guys, anyone over here, if you are over here because of the certificate purpose, let me surprise you guys. We are not giving any certificates. Okay? No, no, I'm kidding. I'm just kidding. You will be getting certificates even if you have just registered with the link that we have mentioned. Okay. So we have given some Google form. If you have filled that Google form, you will be getting the certificate, or else you won't be getting the certificate. Even if you attend the session right now, even if you don't attend the session right now, you are going to get the certificate of participation. And yeah, that's something that we are going to provide to show that yes, you have taken this time for 3 hours on your Saturday evening to upskill yourself and learn something that's going to probably help you by the end of 2024 and literally start earning huge by the end of 2024. All right. So yeah, we are going to provide the certificates. And for the people who are not really aware about that Google form that I'm talking about, I'm just going to share that link in your chat. Just give me a second. I hope the form that I'm sharing is correct. But yeah, this is the one. Yes, correct. Please go ahead and fill this form. And I'm just giving you 2 more minutes of time so that it's exactly 8 o'clock and we're going to start at 8 o'clock for the linear regression part. Fill up this form to just ensure that you're going to get participation certificate for this workshop. And surely please feel free to leave this session if you're over here just for the certificates, because yeah, that's going to be solved by just filling up this form. Okay. Sir, can you tell me in what ways in machine learning used in space sectors? For sure, I'll be giving you a lot of examples where my students are making some of the work in the space sector, and they have also uh, went to a level where using this kind of projects they have implemented. I mean, they have applied for PhD positions in outside of India, right? What do you call this? Foreign countries, right? So yeah, in foreign countries, how they've used this kind of projects related to space sectors to secure a position as PhD and work in multiple companies outside India also. So the kind of projects that you can do over here with respect to machine learning in space domain, especially, is that, for example, see, I've talked about supervised machine learning a lot till now, right? Image classification, let it be, for example, text classification, or a simple machine learning classification model. So all of these things can be implemented in the space sector. Some of the famous things that my student, like, not famous, but some problem statements that I am able to recollect right now on the spot is that, let's say, for example, you are having the images from gravitational waves detector. Okay, I'm talking about LIGO, right? LIGO observatories that we have around the world. So you're collecting this kind of data of signals that is going to be telling you that there is some kind of merging that is happening out there in space, some few light years away from us, right? And based on that kind of readings that we get over here, we are able to make this kind of predictions that yeah, this kind of collision might have happened. But now what happens in this kind of data is you get a lot of signals over here that are really highly specific with respect to glitches in the data. There will be a lot of glitches, which is not actually a real kind of uh, data that you are having because of the collision. It could be because of, let's say, a minor amount of earthquake that you might have experienced here on Earth. Okay, something like this. So because of this kind of glitches that is present, LIGO is one of the most sensitive instrument that we have ever developed as human beings, right? So it's very sensitive to capture this kind of glitches. So how you can speed up this kind of process where you are having some of the data, and with the help of that data, you are able to classify if it is some kind of a glitch or is it real a signal. from any kind of merging happening out there in space. So this is one of the prime example, okay, of what you can do with the help of machine learning in space sector. Other thing with respect to this could be literally, for example, if I'm giving you one simple project, it could be like, you are having some of the black and white images, and this kind of black and white images, you are turning it into true colors of the galaxy. Okay, you are turning this kind of black and white images into its true color that you will be able to observe from a Hubble Space Telescope. Okay, so you're going to have a, again, it's going to fall into the category of supervised machine learning, where you're going to show your model that you are having the data of the Hubble Space Telescope, that this is how colorful your image is going to look like with the help of this optical telescope called as Hubble Space Telescope. And if I'm going to pass you this kind of black and white image, will your model be capable enough to convert it into the colorful image that you're like, that is really very similar to what HST is going to help us see. So yes, even this kind of things you can do when it comes to the space sector. This is just some of the examples that I'm giving. You can also work on predicting the threat from near Earth objects. What is the threat from, let's say, an unknown object that you have just discovered right now? What is the threat with respect to the collision of that particular unknown object that's going to have with respect to the Earth? You can calculate all of these things again with the help of machine learning. Okay, you are having some of the detectors on your satellites from which you're getting the data, and from that data you are making this kind of systems that, okay, if you're able to predict the threat from that unknown object that's not even present in our catalog or in any of our databases, right? So yeah, all of these are the examples of how you can implement machine learning in space sectors. Yes. All right, guys, so let's start with the linear regression. Now, don't worry, guys, with respect to the level that I'm going to explain you right now, it might be very difficult for someone to understand, and someone will be feeling like, oh my God, this is so simple, right? But my main motto over here is to give you the basic principles of how you can create your own model in machine learning right now, okay, right in this session. So yeah, let's just go ahead and start this particular thing. Are you able to see my paint screen? Okay. Okay, perfect, guys. So see, the main aim that we are trying to solve right now is with the help of a technique called as linear regression. Okay, linear regression. So what are the things you need to know over here when we talk about linear regression? Now, one warning that I'll be giving you over here is, please don't go on my spellings. I am pathetic when it comes to spellings. My spellings might be incorrect. Okay, but yeah, it's linear regression that I'm trying to explain over here and how it works. If you understand this one thing that I'm going to explain right now, a lot of different type of algorithms that you will see in machine learning, including deep learning that I talked about in the initial part of the session, how to mimic your human brains when it comes to, like, artificial neural network. All of these kind of concepts will become super easy to digest by understanding only one thing that I'm explaining right now. Only this whole process. Okay, now it's not just one thing, it's multiple things that's making one process. Okay. So the first thing over here is always the data. You must have some kind of data. That's important. Okay. Now, what kind of data you're going to have? Because we're talking about the regression model, you need to have some kind of inputs, and that inputs is going to give you some kind of outputs. And because we are trying to solve a supervised machine learning problem, we need to have some kind of target column. All of these things will make sense once I start explaining all of this over here. So yeah, let's get started. So let's say I'm having two inputs currently, x1 and x2. And based on this x1 and x2, I'm going to get some of the output called, let's just call it y. And I'm just going to create one small table so that you're able to appreciate what really happens in real life. Okay. So let's we are having this kind of a table over here. And this table will have these rows and columns, right? So let's just say that I'm having two rows of data and three columns over here. So the main thing you need to understand over here is what are independent columns and what are dependent columns. Independent columns are nothing but your input features. Input features. What are input features? They are the independent columns that you are having. That is x1 and x2 in this case. And what is the Target column over here, the target column is the dependent feature. So in your target column, you are going to say that, okay, based on these two inputs, I'm going to get my some kind of output over here. And let me just fill this data with some random numbers for now. Let me just fill it with some random numbers. Let's say that this is 2.3, this is 1.2, this is negative 0.8. This might be some another weird number, let's say 100. And based on this, you are having some kind of output. Let's say, because it's a regression problem, I can have a continuous values, not just 0, 1, 2 like that, right? It could be any kind of continuous values. Let me just say that's 2.34, and this is minus 3.62, something like this. Any numbers that I'm coming up with, okay, not true numbers. But this is the type of data that you will be dealing with when you are trying to solve a lot of use case with the help of classical machine learning algorithms. Okay, when I'm talking about a tabular data, okay, this tabular data is something that your machines will be able to understand really very easily. Okay, so whatever is the data, you convert it into this kind of tabular format where you are having some of the inputs based on which you have to predict the output. So this is the kind of problem which you can solve with the help of linear regression. Over here, we need to do some of the analysis to understand whether or not if this kind of input variables are related linearly with the help of this output. If you are having this kind of analysis done, let's say that this kind of analysis is already done for our particular use case, and we are choosing linear regression because it's really important. The second step over here comes that based on the data and the analysis that you do over here, okay, the second thing you do is analysis and finalize some models. So let's say that for this is not the spelling of model. You can see that I'm having my spelling mistakes already out there. But yeah, this analysis and the finalization of the model simply depends on this data. Once you're having the data and it's completely in the format that your machines are going to understand, that means is a pre-processed data. Okay, I should say that this is pre-processed data. What is the meaning of pre-processed? It simply means that whatever is the data, let's say it's in the format of text or images, it's converted, it's pre-processed in a way that your machines will be able to understand. It's in the format of numbers. Okay, so let's say that this kind of thing is done. By the way, this kind of thing is taken care with the help of data engineers that are working in your team. Okay, that's their responsibility to collect the data, clean it, pre-process it in a way that your model will be able to understand it. Then comes the purpose of, then comes the role of machine learning engineers, where they do some of the basic analysis to understand what kind of models they need to finalize. They can have, based on the analysis that they are doing, they can finalize some of the models that they would like to try and see how it's working, how your models are able to predict in future. So that kind of step is done. Okay, but let's say that this step is already done and we are finalizing linear regression to be our model. The next step that follows on top of this is to actually understand what is the model that you're using. And because we are using the linear regression, I'm trying to explain how that model works. How the model works. Now, is this really essential? The answer clearly over here is no. Why? Because only for the interview purpose, you need to know how the model works internally. That's going to ensure that you are having enough kind of an idea to understand the behavior of this kind of algorithm and when you should be using what type of algorithm and how basically it works. Okay, so for that purpose, yes, you will be needing to know how the model works. And to be very honest over here, guys, the guys who are paid huge, you might have heard that someone is earning crore, like throughout a whole year or maybe in a month itself. Why they are able to earn this well? Because they are having enough understanding of how a model is working internally. At least once in their life they've understood this thing. Let's say if they're not able to recollect after years of experience, but when they are starting their journey, they are always having this kind of an idea of how a model is working. If they're having this idea of how the model is working, they have this a sense of, okay, this is the algorithm that I'm going to work with, and that's how it's working internally. Okay, so right now I'm going to explain how this linear regression works. And once again, guys, let me remind you very quickly over here. if you understand this one mechanics over here, a lot of algorithms when it comes to machine learning and deep learning opens up for you, and you will be able to understand all of this really very easily. By spending only few minutes on them, you will be able to understand everything. Okay, that's why I have chosen linear regression, because of that reason only. Okay, it's very easy to understand, very easy to implement, at the same time very powerful, because same kind of logic will be implementing in your logistic regression, in your artificial neural network, and so many similar algorithms in, like, in your future stage when you'll be learning about different models. But yeah, let's start with the linear regression. So what exactly is your machine learning algorithm trying to do over here? Okay, first of all, you need to understand the formula. The formula that you are trying to implement in your linear regression is what? Okay, so y that is y is equal to whatever is your input, let's say x1, whatever is your another input, let's say x2, how much amount of contribution your x1 and how much amount of contribution your x2 is making to make some kind of output. So because I'm telling what amount of weightage this x1 and x2 are playing over here, that is going to contribute to the final output, you are going to multiply your x1 and x2 with weightage coefficients. Now, what are these weightage coefficients? These are nothing but your model parameter. Let me just call it as W1 and let me call this as W2. And I'm simply going to add them together. They can be negative, they can be positive. Okay. But this is the kind of formula that you are having. The prime thing that you need to understand over here is this x1 and x2. How much amount of contribution this x1 and x2 is giving to the final output. How do you know about this kind of contributions? Because of this coefficients, which we call as weights of the model. Okay. Now you can just trust me on this, that if you are going to add one more term over here, which we called as bias, if we add one more model parameter, which we call as bias, BIAS, okay, bias, that's eventually going to help you get even better results. You can just try to think of it in that particular way. I'm not going to go into the very details of what is bias over here and why do we use it, because it's going to take a lot of time. But even if you don't have a bias, still your system will be working fine. But by having a bias, you are making sure that your model is going to predict in a better way. Okay, the whole function of machine learning training purpose will be done very efficiently by adding one term that we call as bias. So what are the model parameters over here, guys? It is W1, W2, and B. W1, W2, and B. These are your model parameters. Model parameters. Now, what is the main job of this machine learning algorithm over here? Role of ML model over here. What is that role? The role is to find out the best combination of W1, W2, and B, such that if I give any X1 and X2, it's going to predict some kind of Y that is very close to the actual value. Okay. I'm going to pass in, for example, let's say if my model is trained enough that your model is giving you what is the best W1, what is the best W2, what is the best value of B. You are having this kind of combinations of W1, W2, and B in a way that if I'm going to give 2.3 as the value of X, 1.2 as the value of X2, okay, X1 as 2.3, X2 as 1.2, and there are some values of W1, W2, and B that your model is predicting. So based on that, if I'm going to get the output, I'll see that if my model is trained really very well, it's very close to this. It could be, let's say, for example, 2.3, 39999, something like this. It could be, right, or I should say 3399, something like that, or maybe 2.400, something like this, very close to the actual value, or exactly the actual value, whatever it could be. The main role of the machine learning model over here in the linear regression is to come up with the optimal value of the model parameters with the help of a training. Okay. Okay. Let me just repeat it for one last time. The main role of ML model is to update the values of model parameters until they are until they are optimal or optimum. I don't even know what do you call this, but yes, until you get the best values or the best combination of this model parameters, until that you keep on training. Okay. And once you find that, yeah, these are the best combinations of W1, W2, and B, I'm going to get my training completed over there. So the role of machine learning algorithm over here in the linear regression is to just get the best values of W1, W2, and B. That's all. If your model is able to do this, your machine learning concepts are clear over here with not just linear regression, but a lot of different kind of models that you might be seeing in your future. Okay, with only this concept. All right, guys. So yeah, that's how you understand that how your model is working internally. Okay. Now you might be asking that, hey Rohan, if I'm using a formula over here, how is this a machine learning in the first place? So to answer that question, in let's say if you're having some kind of different kind of data, and for all the data you are having different type of formulas. That's a different thing, right? For every different type of model, I mean for different type of data, you have different kind of formulas through which you can make some kind of output, and that will be exact output because there is some established formula with respect to that, right? There is some established connections with the help of formula to get outputs accurate that are accurate. But now what is happening inside this ML model is by using only one formula, by using this simple one formula, it's going to work on any kind of data set, even if it's not working well enough, but it's going to give you some kind of predictions on working by just this particular formula. That how with respect to W1, W2, and B that your model is going to predict, your outputs are really very close to what you see over here. So that's where the machine learning is kicking in. You are trying to have this kind of W1, W2, and B that are best, that's going to work with any kind of X1, X2, whatever data could be. Okay. If I change these numbers, it's still going to work with respect to that if the training is done in a proper way. All right, guys. Any kind of doubt so far? Are you guys able to understand this? Were you able to understand how this ML models, especially linear regression, works? Okay, Gauri is saying yes, she has understood this. Anyone else over here who is able to understand this properly? We are having Krish, Anand, Raj, Aditya, Sadhya, and 9 more people over here. Okay, great. Great. Fantastic. Now, this is just one part that we have covered. That's one part that we have covered. That what is the whole process of how machine learning works when it comes to linear regression. But how the training works over here. How does the training work over here? Okay, let's try to look into that. So for that, I'll have to create a new page. I'll just save this part very quickly. Okay, I'm going to create a new page over here, and I'm going to have yeah, this black page, and I'm going to start with the fourth part, that is how to train your machine learning model. Train your ML model. Train your ML model. Which ML model? Linear regression. Okay. So how does that training work over here, guys? Note that the main thing that is important over here for us is W1, W2, and B in our case. Now let's say if I'm asking you a question over here very quickly, that let's say if I'm having only one input, let's call it X1, and with that X1 I'm going to get some kind of output. Can you come up with one formula for me that's going to be useful for the linear regression? What will be my y equal to in this case, where I'm having only one x that is input and one output? In that case, what will be the formula? I'm giving you 1 minute to think. I am going to expect you to, I want at least one person to give the correct answer. Let's see if you're able to. Well, it's completely fine, even if you cannot give the correct answer, but at least give an attempt. At least give one attempt. That if I am having only one input and if I am having one output, what will be the formula of the linear regression? Yeah, go ahead. In the previous slide, what we had seen was that if you are having x1, x2 with y, the formula was y is equal to w1 x1 plus w2 x2 plus bias, right? This is something that we were having. But this was with respect to two inputs. But now what if I'm having only one input? This is something that I'm asking. Nicole says it's wx plus b. Raj is saying w1 x plus b. And this is the correct answer, guys. This is absolutely correct. You have understood the basic way of how a linear regression works. Okay, because I'm having one input, in this case I'll be having only one weight for that x1. And yes, if you want to include bias, it's fine. If you don't want to include bias, it's still fine. But just because we know that bias will always help you in your training process, let me also include the bias. So this is something that you are going to have wx1 plus b if you are having only one input and one output. And this is exactly what you're going to build in, like, in the last part of this particular workshop, that how with the help of this x and y you can create your linear regression model from scratch. Okay, so over here your main job will be to update the values of w and b until they are optimal in a way that whatever x that I'm going to pass in over here, it's going to give me very accurate output. That's something that you're going to learn. Okay, how you can do this. So how does your training of your machine learning model works over here? That's something that I'm going to explain right now. Okay, so over here you try to focus on optimization algorithms. Optimization algorithms. Now there can be a lot of different kind of optimization algorithms. The one that I'm going to share with you guys is called gradient descent. Gradient descent. Okay, the reason I have chosen gradient descent over here is because a lot of advanced kind of optimization algorithms that you will encounter in your future will be somewhere using, in one or the other way, the gradient descent. That's the reason why I have chosen that specific thing for our workshop. Okay, so how does this gradient descent basically work? Remember, the name itself suggests that it's trying to optimize your algorithm in a way that, let's say, initially you are going to pass in some random values over here for w1, w2, and b. Random initializing. Okay, you're going to randomly tell that w1 is equal to some falana value, w2 means some dhimkana value, b is some, like, any kind of value that comes to your mind, you can take that. Okay, the goal of this optimization algorithm would be to take that random value and give the best possible value along with the w2 and b, that with this combination you will be getting the accurate result. So how does the gradient descent work over here? Let's try to capture this kind of ideas. Again, guys, if you are feeling even for a second that it's getting overwhelmed, it's completely fine. I don't really expect even a single person over here to understand everything 100%. Okay, but that will be my goal, that I make at least one of you understand everything in at least a way that you are able to appreciate that these 3 hours were pretty much useful for you, right? That's the main motto. Great, guys. So how does gradient descent basically work? For this, you need to understand a concept of a loss function. Okay, so on the side, I'm also going to explain you the concept of a loss function. Now, what is a loss function? Don't worry about this new term that you are seeing. Okay, it's completely fine. There will be new terms for any different kind of concept, but yeah, just try to hold on for some time. You will be surely be able to understand everything. You can call it as a loss or a cost function. Everything is fine. So what is the purpose of this loss function or a cost function? Let's try to understand that. So I told you that you will be having your some kind of data in which you're having some x1, you're having some of your x2, could be any kind of value, could be anything. And on that basis, you're having some kind of actual output that your model is going to see, right? It's going to see some kind of output. Let's say, for example, 8.2, something like this. This is your actual output. This is your actual y. Now, what's going to happen with the help of machine learning? It's going to use this random values of W1 and W2 and B also to make these predictions with the help of this X1 and X2. Okay, so my Y prediction is what? Some random value of W1. Let's just call it as 0.3. Let's just call this as 0.1 and let's just call this as 0. So with the help of this Y prediction and this random values that I'm having over here, it's going to make this formula as 0.3 into 2.3. I'm taking this W1, multiplying it with X1 plus what is W2? It's 0.1. Multiply that with X2, that is negative 0.3, and plus B, because initially the value of B is 0, I'm going to pass in 0. It's going to give me some kind of output. It might be very close to 8.2 initially itself, or it might be way off than 8.2. Let's say, for example, that I'm not having any kind of calculator with me, and I won't even bother you guys to give me some kind of value. But yeah, let's say that this kind of value is pretty much off. Let's say I'm getting output of 100 point something, 100.3 something. Assume that this value is something completely off, very not very close to the actual value. So what's going to happen? How is your model going to understand that this value is very far from the actual value that it needs to predict? That's where the loss function or the cost function comes into the picture to help your models understand that, okay, yeah, wait, the prediction that you're able to make is very far from the actual value or very close to the actual value, right? So that is done with the help of loss function. The one that we are going to use over here is mean squared error. Mean squared error. What does that mean? Whatever is your y actual value for one row, then what is the prediction that your model is giving? You subtract it from that. That is the error. You square that error and repeat this process for all the rows that you are having in your data. Let's say if I'm having hundreds of rows. So for each and every row, you know what is the actual value. Your model will be able to tell you the predicted value based on these values of W1, W2, and B, or whatever is the model parameters at that time. You will be getting this Y and Y predicted, right? So Y cap stands for the prediction value. The normal Y without this kind of cap on top of it is the actual value. So you take the error for each and every cases, you square it up and then sum it up together. You sum it up together. This E symbol is nothing but summing them up together. And then you're going to do it for the first row all the way up to the last row that you're having. Okay. So what are you doing? We took the error, we took the square of that error, and now we need to take the mean of that. So what is the meaning of mean? You take the average of the squared error. So error that are squared for each and every rows, you're going to take the mean of it. So let's say because there are n samples in total, you're going to divide this whole value by n to get that average value out. And therefore, I'm just going to multiply this with 1 by n. Dividing with n or multiplying this with 1 by n is just the same thing, right? So this is your cost function that you're going to use over here. Is this the only one cost function or the loss function? Again, the answer is no. There are multiple different loss functions that you can use to tell your model that, hey, how much close or how much far you are from an actual value, any kind of function, but it should be related to whatever kind of algorithm that you're using. Okay. For example, most popular for the linear regression, because I'm experienced, I know that the mean squared error is going to work like a charm. That's why I'm using it. Okay, it's not this completely random loss function. I know that it's going to work well with the linear regression. That's why. And for now, just know that, okay, you are also aware about this, that for mean squared error, it's going to work fine when we talk about the linear regression. Okay. So let's say that we are having this kind of a loss function. Again, what is the purpose of this loss function? The purpose of this loss function was to tell us that how much accurate your model is able to predict based on this W1, W2, and B, because the predictions you are getting is because of these parameters, right? So yeah, once you get the predicted value, if it's very far from the actual values in almost all the type of rows that you are having, it's going to give you a very large value of mean squared error. At the same time, if it's really very close to the actual value, this value will be minimal in that case. So lesser the cost function or the loss function, the better it is for our model. Right? It means it's more accurate in that case. Right. So yeah, this is something that we need to make, that in at the end of the training, this error should be minimum as much as possible. It could be zero, or in real life, you don't really go to the zero. You will understand the reason behind that in a while when you will be starting the coding part. But yeah, the main aim of this kind of loss function is to, go till the minimum value that it can get with the help of optimization algorithm. Okay. So to understand the gradient descent, it is important to understand what type of loss function you are using. And clearly we know that over here, this mean squared error, because it's of a parabola type, you are having a square on this data. It's going to be some U-shaped curve. It's going to be some U-shaped curve. You might have some kind of values on the x-axis. What are these x-axis values? These are your model parameters that we call as theta. Let me just use some other color so that it's not matching with this thing. Let me just use, let's say, brown, for example. So this W1, W2, and B, either of it, we are going to do the same process for all of these things, W1, W2, and B, for all of them. And commonly, we typically represent this as a theta. Theta could be anything, W1, W2, and B. And we do this kind of process for every model parameter. Okay, just keep that in mind. And on the y-axis, you are having the error or the mean squared error, MSE. And now, because we can clearly see that it's a parabola type, it's going to look something like this. It's going to look something like this. Okay, where clearly we can see that the minimum value of the error that you are going to get is over here at this value of theta. This will be your theta optimal. Okay, this will be your theta optimal, where you are getting the minimal amount of error. It could be zero. It could be anything more than zero. It could be 1,000 also. The minimum possible error could be 1,000 also. It could be 1 lakh, 1 crore, whatever it is. But in the whole function, there will be at least one minimum that you will be able to see. And your goal will be to get to the global minimum. Global minimum means that even if your loss function is like this is your global minimum. There is no minimum value like this. Okay, let me just draw it in a proper way. This is the kind of function. So this is your global minimum. This part is the global minimum. This is not the global minimum. These are called local minimums. You need to find where is your global minimum. Okay, and because in the mean square error, it's a simple U-shaped type of parabola, you have only one minimum value. So on what value of theta? On what value of theta are you going to achieve that minimum value? And how can you get to this optimal value of theta? That is optimal value of W1, W2, and B. How will you get, with respect to all of these model parameters, the optimal value, because of which you get the minimum error? That's where the gradient descent starts. Okay, that's where the gradient descent starts. So how does this gradient descent work? Okay, let me explain you that part. But before that, any doubts in understanding the cost function, guys? Any doubts in understanding the cost function? I guess there is some doubt. W1 x1 plus b is equal to y. Oh yeah, that's correct. So can it be like W1 e to the power of W2? It, for linear regression, we don't have that kind of thing, Aditya. In linear regression, you at least need to provide what is your input, that is x1 in our case, what is your model parameter due to which the weightage of that particular x1 will be decided. That is your W in this case. If you're having two inputs, so it will be W1, W2, like that. Okay, now Raj Shinde is saying that, and if it gives zero, then it means it's perfect value. Yes, that's correct, Raj. But that kind of zero is very impossible. In real life of data, you will hardly see that any loss function is going to zero. It's hardly possible. Okay. Maybe in the some kind of data set that you're learning as a part of your example, for that, maybe the data set is designed to give you zero result, but in real cases, you won't get absolute zero like this. Okay, it's very rare. I have never personally seen my results going to zero, exact zero. Okay, that's the beauty of machine learning. It's giving you predictions as what, according to it, based on its training, able to give you the answer, and hardly it will go to zero. It's not perfect. Machines are again not perfect, but better than humans at doing some kind of task if the training is done in a better way. That's it, right? Great, guys. So this was with respect to the second slide that I was really trying to show. Now comes the next thing, the gradient descent, guys. The most important thing that you need to understand right now that's going to help you in the coding part. So gradient descent. Now again, because this is an optimization algorithm, there is some kind of formula going on in the backend. Okay, there is some kind of formula. And I'm trying to explain how does that formula comes into the picture. If you're able to understand it, you understand how gradient descent works. Simple as that. So let me give this attempt to explain each one of you over here. We started with some 30 students. Currently, we are having 14 students only. Okay, so that's really good. All of you are really interested to understand this kind of things and you are getting some kind of value. And that's something that I really wanted, that at least a single student, even one student is there, I'm going to be happy, right? That, but yeah, it's really very difficult, guys, to understand everything in one session. Still, you are trying to understand a lot of concepts, right? That's something that I like. If you're having this kind of fighting spirit to try to understand no matter what, if we have decided to do something in this evening of Saturday, I complete that part no matter how difficult it gets. And because you're having this kind of opportunity to ask me any kind of doubts, I really appreciate that you start asking your doubts if you're having something, and like, keep everything crystal clear if possible. Okay, but yes, let's continue with the gradient descent part. So how does a gradient descent work over here? Let me just explain that. So because we are using MSE as the loss function, you know how the graph is going to look like. So I'm just going to redraw the graph very quickly. Okay, you can also make it touch 0, but because that does not happen, I'm just making it up. Okay, this is your mean squared error, and this could be any of your model parameter, W1, W2, W100, bias, whatever it is. Our goal is to get to this specific point. Let me just color it with red. And this is your theta optimal. So how does your gradient descent do this? Very simple concept, guys. Very simple. Just pay proper attention over here and it's going to be very simple. That's my promise. Okay. I'll just mention the formula over here, first of all. To update the value of your theta, to get any kind of updation in the value of your theta, you need to know what was the previous value of the theta. Then you have a negative sign. That means some subtraction is going on. And then you have some alpha. What is this alpha? Some kind of step size. Okay, there is a name that is given to this alpha, which you call as learning rate. But don't get into the naming part. Just think of it as a step size. And the most important part, guys, the most important part is coming right now. That is the gradient. The name gradient descent is coming because of that term that I'm going to write over here. That is the partial derivative of that loss function or the cost function with respect to that theta. If it's W1, so what is the partial derivative of the loss function with that W1? In this case, and because I'm trying to generalize it, I'm going to call it theta. Now I'm very well aware about this one thing. Not a lot of you are coming from the mathematics background, and it's completely fine. You don't need to be expert in mathematics. You just need to know about one thing, that there is a thing in mathematics, a concept in mathematics that we call as partial derivatives. If you know the partial derivatives, you will be able to get this partial derivative of loss with respect to your theta. If you don't know, it's completely fine. If you want to understand it, then obviously you need to know about how the partial derivative works. But let's say for now, for the use case of our workshop, let's say that you know already how this works. And I'm going to give a formula over here that let's say if you're going to work with y is equals to wx plus b kind of data, what will be the derivative of the loss with respect to w, some kind of formula, and what will be the derivative of loss with respect to your bias? There will be some kind of formula. Let's just assume that you are already aware about how to do this kind of partial derivatives, and there will be some kind of formulas. Okay, it's, to be honest, one of the simplest concept you will see in mathematics. It's not at all difficult. It's even simpler than the normal differentiation, if you ask me. Okay, and for those who are already experienced in the partial derivative, must agree with this. But yes, let's just for now assume that you know how to calculate the partial derivatives of the loss with respect to any kind of model parameter, W1, W2, W9, W10, whatever it is, or bias. Okay, we are just giving a general term with theta, so that's why I've written theta over here. So now let's say in the first attempt, when we are randomly assigning some value of theta, I am going to say that I'm starting from here, for example. Okay, this is my cross. This is my theta 1 that I randomly initialize some kind of value. Could be W1, could be W2, could be any model parameter. Now my main goal is how, with the help of gradient descent, by using this formula, I can reach to this part. Okay, just pay attention onto this loss term, guys. This loss term is going to be really very useful for you. Okay, what's going to happen over here? You're going to take the gradient. What do you understand by taking the gradient at this point? It's nothing but what is the gradient of the tangent that is parallel to that point. That's it. This is the point. Try to draw some kind of tangent. Okay, I'm not able to draw a proper tangent, but just assume that it's a tangent. What is a tangent? It's just a line that is passing from only one point on this curve and it's not touching anywhere else. Okay, so something like this you can try to understand. Okay, it's touching at that point but nowhere else. So now what is the value of this? You will be able to find it if you have the formula, or else you will have to draw this kind of tangent and do it manually, right? It's part of a burden. You don't do that. You have the formula and pass in the value of theta. It's going to give you the output of that gradient. But the logic that I'm trying to explain over here is something that you'll be able to understand it now. What's going to happen, guys? Let's say if I'm starting with my value on the right hand side of the optimal value of theta, I want this theta value to go to the left hand side. If I'm starting with the theta 1 value over here, I want it to go to the right hand side. I don't want it to go to the left hand side. I want it to go to the right hand side. So in either of the cases, I want to make my theta value go in the opposite direction from where I have started. If I'm to the left of the optimal value, I need it to go to the right. If I'm on the right of the optimal value, I want it to go to the left. So that's the reason why you have a negative sign over here. And that's the reason of this negative sign. All right. So now coming back to this step 1, that we were having some initial value of theta 1, random value of theta 1. Now with the help of this gradient that you are calculating over here with some kind of formula and some kind of step size. Okay, you can, this is a hyperparameter. You can try to change this different values of alpha. Let's say that you are using 0.01. This is the step size. So how much amount of contribution of the gradient is going to be there in order to change the value of theta? How much amount of contribution this part will have to change the value of theta? That's nothing but your alpha. Okay, more the alpha, it will be contributing a lot. Lesser the alpha, it will be contributing less, right? I'm just choosing a typical value that you see in the machine learning world, that is 0.01. So once I'm having the value of this gradient, okay, it will be positive in this direction. And therefore, what was the theta 1 value over here? Theta 1 value will be subtracted from this much part, 0.01, and then whatever was the value of the gradient over here, whatever was the value, it's going to give you the theta 2 value. It's going to be closer to this optimal theta as compared to what it was originally. Let's say it's coming over here. This is the change it's making. This is theta 2 now. Again, do the same process. Whatever is your gradient over here, whatever is the gradient value, with the help of this formula, pass in the value of theta 2, it's going to give you the output of the gradient. Once you know this gradient, you take that theta 2 over here, subtract that 0.01 of that gradient value. Okay, this is the gradient value. And this is going to give you theta 3. So what's going to happen? This time you're going to be very close to the theta optimal. Let's say over here. And now if you try to draw a tangent, just look into the beauty, guys. Now if you try to draw a tangent over here, let's say it's going to be very much parallel to the x-axis. Okay, the moment you're going to go to the, like, whenever you're going to go to this optimal value, you will see that it's completely parallel to your x-axis. This is where the gradient will be equal to 0, right? So anywhere, if you are going closer to the this point, anywhere closer, let's say over here or from the left hand side, if you are getting closer to this minimum point, guys, what happens? You will see that the gradient values are approaching 0. Okay, if I take the tangent over here, let's say if I'm drawing the tangent over here, it's going to be very much closer to 0. Basically, that's what I'm trying to prove over here. So what's going to happen? Once this kind of updates are happening, let's say theta 3 minus 0.01, of a very small value, let's say 0.00000008. This is the value of the gradient that you're able to achieve. In the third attempt, you are going to get a theta 4. But now, imagine this thing, guys. Because this value is so small, very small value, the updation is not happening over here, or it's happening by a very small amount. The updation is happening by a very small amount. So I can say that clearly my theta 4 is equal to theta 3. There will be a little bit of update, no problem. But yeah, almost if you round it off, let's say correct to 13 decimal places, it's going to give you the same answer, for example. Okay, so like this, what you are doing with the help of gradient descent, you are taking the initial value, you are having some of the step size, you are having some gradient value, doing some calculations, updating the values of theta. If I had started from the right hand side, I would have started from, let's say, for example, over here. I go over here in the next attempt. In the third attempt, I'm over here. The moment I start approaching towards this optimal value, the updation will happen very, very slow, very, very slow. And once you are, let's say, you want the repetition in your theta values, let's say correct to 13 decimal places, that if the theta values are repeating for 13 decimal places, it's the same value. It means the optimal, we are very close to the optimal theta, and it's going to take a lot of time to update this. But because I'm achieving this kind of accuracy, I'll stop my training over there, because correct to 13 decimal places is a huge value. It's a huge value of accuracy. So this is the kind of thing where we understand the concept of gradient descent, that how starting anywhere on this graph, any theta value, any w value, any b value, wherever I am, thanks to the gradient descent algorithm, that's going to work in a way that wherever I am, it's always going to throw my that model parameter to the optimal value that is possible. Always. That's the purpose of gradient descent. Use the gradients with some step size. Okay, we call this as learning rate. Okay, let's say if this alpha value is very high, let's say 0.9, what's going to happen? It's going to throw the value to the right, this side. Then it's going to throw it to this side. Then it's going to come over here. So this kind of zigzag pattern will be there. Overshooting will be seen over here. If the theta, if the alpha value is very small, in that case, what's going to happen? It's going to update very slow. After this, it will be somewhere over here, then over here, then over here, then over here. It's going to update very slow. So you need to find out the right combination of this alpha with the whatever kind of task you are using. And that's why we call it as a hyperparameter. This is called as hyperparameter. You always, let's say, for example, try with 0.01. Then maybe you try to decrease the value of alpha. If you think that the model is taking a lot of time to train, you try to increase the alpha value by a factor of 10, for example. Okay. If the training is very fast and your values of weights are overshooting, the values of biases are overshooting, in that case, you try to reduce the value of alpha. Okay. So yes, guys, this is how the gradient descent basically works in order to start from a random value and get to the optimal value. That's how the training process will happen if we are choosing the optimization algorithm as the gradient descent. Let me have a quick summary of what we have done over here. Okay, we had loss function that was mean squared error, right? It was mean squared error. So from that mean square error, we took its derivative with respect to, let's say, W1, W2, theta, whatever it was. Bias, whatever it was, right? So with that gradient formula, you're going to pass in the current value of your model parameter, multiply that with your alpha value, the step size, and whatever is the current value of theta or whatever is the model parameter. You do this kind of calculation, you update that particular model parameter. You repeat the steps until the gradients are going very close to zero. The moments it's going to the zero, it means the updation part is not happening. Or if it's happening very, very slowly. So that's where we conclude that the optimal value of theta has been achieved, whatever it could be. W1's optimal value, W2 optimal value, B's optimal value, whatever you are trying to train at that time. Okay. So yes, guys, that's how the gradient descent algorithm basically works. This is the end of understanding. Now we are about to jump into the explanation part. Okay. But yeah, before that, any kind of doubts, guys, any kind of doubts, I can still see that there are 14, or I should say now it's 13 people that are staying in the meeting. I really want that you are able to understand this. Only then Only then guys you will be able to enjoy the coding part, or else coding is just going to be very hectic. Okay, it's compulsory that you understand over here. Okay, if there is anything that you want to ask, you can maybe unmute yourself or pass it into the comments over here in the chat. I can see one doubt. Sir, can we also use Newton's formula because it is kind of similar to the gradient descent algorithm? Yes, what's happening over here is you choose any kind of algorithm that's going to update the values of theta in a way through which you are going to get to the optimal value that is possible. You can choose any kind of optimization algorithm for that matter. Okay, I am just choosing one, that is gradient descent. Why? Because this is one of the most popular and famous you will see that is being implemented even in the highest level of optimization algorithms that you will see in your future. Like for example, Adam optimizer is there, right? A lot of different kind of optimizers. Okay, you will be able to understand them if you are having the basis of gradient descent. All right. But yes, this is not the only one. You can use any kind of optimization algorithm that can help you get to the optimal value. All right. Yes, guys. Any other doubts if you are having, please share it with me over here. Are you all able to understand this? Give me a response with maybe a thumbs up or maybe write in the chat if you're able to understand this. If it's getting any overwhelming for you, still let me know that it's getting overwhelming for you. I would like to know if it's really getting overwhelming for any one of you who is present in the meeting. So anyone over here for whom it's very tough to understand all these kind of things? Anyone like that in this session? Great. We are about to jump into the coding part, guys. Okay, we are about to jump into the coding part. Before that, let me give you a quick recap by going into the PPT and just browse through very quickly within just 1 minute to give you this kind of visual beauty experience that will help you understand even things in a better way. Okay, so I'll just stop the screen share. I'll first of all save this, and don't worry guys, I'll be sharing all of this kind of notes with you that I've created over here. Okay, so yes, I'm going to stop the screen share and about to share my PPT. Just a quick revision, guys, over here. The two things that you understood over here is called forward propagation and the backward propagation. This kind of terminologies you will use once you start learning neural networks, that is deep learning. But still, I have incorporated the same kind of terminologies over here so that it makes good sense to you when you start doing your deep learning part. So when you are starting to compute your output in order to make some kind of predictions, you use model parameters, that is your W1, W2 bias, or whatever kind of W's, whatever kind of bias you are having this model parameters, you use it with the inputs to get some kind of predictions. Now with the help of these predictions, you compare it with the actual output, and that is what we check is by compute the loss to check the difference between the output and the target variable. It could be mean squared error or any kind of different loss function that you can think of. Okay, that can go very well with the linear regression. Okay, so that's the kind of loss function that you calculate. Okay, what is happening? Initially, you're having some kind of model parameters with the dataset inputs through which you get some kind of predictions. With that predictions, you compare the output that you are having originally with the help of loss function. So that's your forward propagation. Once you get the output, and if they are not very close to the actual value, if the loss value is very high, what happens? The backward propagation happens, where you are updating your model parameters, where the gradient descent is going to work in our case, because we have understood gradient descent over here. Okay, so what's going to happen? We are going to use some of the optimization technique to minimize the loss that we have computed in the previous step. That's the main aim, to optimize the loss function, means get this model parameters in a way that you get minimal loss possible. Okay, and you do this with the help of gradient descent. That's one of the way through which you can do it. Right now, these are the things that I've explained you. Now if you combine in format of a training process, how does the training work? So for one update, you have a forward propagation and backward propagation. You are going to update some of these values. For the next run, for the next iteration, again the same kind of things are going to happen. You're going to use your model parameters, get some kind of outputs. With the help of that outputs, you will be computing the loss function. With that loss function, what will be happening? You will be getting an idea if your model is accurate or not. If it's not really accurate, you again do the backward propagation, and this loop continuously goes ahead. And this is what we call as the training process. Until you get the optimal values, the training will keep on happening. Okay. Once the training is done, you basically test your model. That's it. How good, how better your testing is done. Ah, how good your training is done. Okay. So yeah, that's the purpose of testing. So that's the complete workflow of the linear regression that you're going to see over here. And if I ask you this question over here, guys, which of the following option are correct for supervised learning? Is A correct, B correct, C correct, or D correct? Out of these four options, which one is going to be solved with the help of supervised learning? Give me the answer in the chat. Clustering and the dimensionality reduction, classification and control, regression and classification, or association and clustering. Which out of these four options is correct? Prince is saying C. What about others? Aditya is saying A. All right. What about others, guys? Anand, Raj, Poonam, Georgina. Okay, I'm very good. I'm very bad at pronouncing the names also. But yeah, I hope I pronounce your name in a proper way. Then we are having Priyanshu, Rudransh. Okay, great. A lot of you are saying C, and C indeed is correct. Aditya, A is not the correct option because clustering and the dimensionality reduction are part of unsupervised learning. Okay, it's not falling into the supervised learning. All right, great, guys. C is the indeed correct answer. Now, which of this belongs to the forward propagation and the backward propagation? I'll just leave this particular thing because I have already spent a lot of time over here. Uh, Create your ML model to predict something. It's going to be forward. Initialize the model parameters again will be your forward. Update the model parameter will be your backward, where the gradient descent basically works. And compute the cost function. I explained you that the computing the cost function is a part of forward propagation, right? So yeah, that's how this works. This is the gradient descent optimization algorithm, and this is how it looks, guys. This is how it looks. You start with some random values of whatever parameter it could be. You are implementing over here absolute error. Okay, you are trying to get absolute error over here. We are trying to have squared error. They are having absolute error. Even that is fine. Okay, but just look over here. Initially, it was having some random line, but how well it is going to fit these points, how well you get this line of best fit by slowly getting to the correct value of p. This is what is called linear regression. After your training, this is how it's going to look like, guys. Okay, this is how it's going to look like. All right, and yeah, that's that's about understanding how a linear regression works. And this is a complete machine learning workflow, guys. Whatever I'm explaining right now, that's not going to make you expert in all of these categories. It's making you expert in only one thing. That is the second part. That is modeling. Okay. The first part that you're seeing over here in the green is part of something that we call as data engineering that I had mentioned in the starting of the workshop. Data engineering is like data engineers focus on getting the data, cleaning the data, pre-process it in a way such that machines can understand. Then comes the role of machine learning engineers. They do all the things that is there at the end. Okay. Currently, you are learning one of the skill sets, that is to develop a model and train it. After training it, you are also going to validate it. Once this step is done, let's say your coding and your AI tool that you have created is of a level to convert it into some kind of a product from which you can make a business. That's where the deployment starts in. Okay, deployment is basically like, it's nothing but you are pushing your whole code into the production environment, where production is nothing but like, you are going to convert it into a way that's very easy for your users to use it, very fast at the same time, and giving very accurate results. That is what is a deployment that you are doing to the production. Okay, then you are going to continuously monitor and update your data, continuously retrain your model, so that you are always keeping your model up to date, even with the new type of data that your model is going to have. So how do you connect this kind of pipeline? That is where machine learning engineers come. Okay, out of which I'm just teaching you this kind of part. Okay, you can do this in a proper way with the something that you call as ML ops, machine learning operations. If you are aware about this kind of framework in machine learning, that's how you do this in an appropriate way. And trust me guys, this is one tool you must definitely master in 2024 if you want to get a really good package. Machine learning operations is something that you should focus in 2024. Okay, but it's only possible if you know how to do these two things. Okay, and that's something that you're going to see over here today. So what I'm going to do is I'm just going to copy this code over here and paste it into the chat. So anyone over here who would like to code along with me can use this. And yes, you can basically see you're not going to code everything. Okay, only certain part of code you will be coding along with me, and you will see that how easy it is. Okay, there is no need of you to know Python. There is nothing that you need to know. Simply follow whatever I'm saying and you are good to go. You are going to implement the same stuff that we have learned, all of these things, but now in the format of coding. How you can convert all of this into the coding, that's something that you're going to focus on. Okay, and yeah, we are about to start this. I'm going to give you 5 minutes of break. After 5 minutes, I am going to start the coding part. You simply need to go to the link that I've pasted in the chat. That's it. It's going to update all the codes that I'm going to write over here. So it's going to, like, update all of the things that you are doing and keeping you on the same page. So just in case if you want to create a copy of it, what you can do is you just try to save it by pressing Ctrl+S. You try to save it and save it somewhere else in your drive. Okay, it's going to create another file where you can have this kind of edit of your own. Okay, so I'm giving you 5 minutes of time to set up everything. And yeah, we are going to start at 9:10 guys. Okay, at 9:10 we are going to start. Till that time, if you're having any kind of issues in setting up, you can let me know. I can just show it to you how you can exactly set up. Let me show it to you just a second. We are going to start at 9:10. Okay, exactly 9:10, the coding part. I'll share my whole screen. Okay, now what I need to do is I simply need to, just a second, let me just, yeah, I simply need to copy this part. Okay, I go to the new tab and paste it and press enter. That's it. Okay, and you will be able to see that all this kind of things is there. And clearly you don't need to code everything. That's why some part of code is already there, so that you don't have to code everything. But you can see that there will be some kind of empty places, and all of this kind of places will be getting filled automatically the moment I start coding in my notebook over here. Okay, I'm having this notebook. I'm going to start the coding. Whatever I'll be coding over here will be getting filled in this notebook. So let's say if you want to create your own notebook, what you do is you just try to save this model. Okay, I'll just try to do some kind of changes. Actually, it won't be showing me in this particular web browser. So let me open some new web browser. Just give me a second. I'm just going to maybe try to change something over here in the coding part. Let's say I'm trying to have a 0 over here, and then I'm trying to save it. Okay, I'm going to save. I'm going to get this kind of option. You cannot save changes. Why? Because I'm not allowing you to save the changes in my actual file, because everyone is going to use it. Therefore, you click on save a copy in drive. Once you click it, what's going to happen? You are getting a new notebook where you can do this kind of changes and save it in your Google Drive. That's it. So whatever I'm going to do over here, okay, I can just close everything. Now, if you try to do anything over here, let's say I'm trying to have 0 over here as well, and then I try to save it. Now it will do it without any kind of problem. Okay. So please get started with this kind of things, guys. And I'll be starting this coding part in just 4 more minutes. Okay. Yes, guys. By that time, if you're having any kind of doubts, you can let me know. Yeah. I'm just going to stop this here. Yes, guys. How many of you are going to code along with me? Just raise your hands. It's completely fine. Even none of you raise it, but I just want to see if there is anyone. Great, guys. There are 3 people. 4 people, that's perfect. Like, no, I was imagining there will be no one who will be like, having this much amount of enthusiasm that after spending 2 crucial hours to understand all of this, you will be having the capacity to code. So that's amazing, guys. Fantastic. I'm glad to see that all of you are going to code along with me. And for especially like just I'm just giving a quick kind of warning. If you are new to Python, guys, you will be 100% lagging behind. The code that I'll be writing, the code I'll be explaining, you won't be able to catch up with both the things. So if you are someone who is very new to Python, you just try to observe how the coding is done. That's it. That's the only job you need to focus on. How the coding is done. You don't try to implement along with me, because you won't be able to have the fun that I want you to get by understanding how this kind of process that I've explained in the paint, how can you convert it into some kind of actual thing. Right? So yes, if you are someone who is new to Python, please don't code along with me. But it's your choice. Okay, if you want to experience it, why not? Who am I to stop you, right? So yeah, if you want to experience it, you can do this kind of process. Great. All right, guys. So any one of you over here who is facing any problems to launch your coding notebook or something like that, you can let me. All right, great, guys. Great. This is the last segment before I tell you the proper roadmap with free resources through which you can master the skills. And trust me, guys, it's not within 2 months you will be able to master it. Within 5 months, no, you need to spend enough time according to your capacity, according to the time that you're having. For some people who are already working in some kind of job, they might take some more time as compared to a student who is not doing anything. He's just in a, let's say, for example, school. He's enjoying his vacations right now. He can spend or she can spend, let's say, for example, one complete month dedicated to it and can be 10 times ahead of you who is working in a job currently. It's completely dependent on individual. Okay, how much amount of time they are able to contribute. You just need to ensure that all the skill sets that I'm mentioning in the roadmap, you are good with at least one of them. Okay, at least one of them is going to help you at least start getting good kind of opportunity to start applying, and then you can start learning different things by being a part of a company. All right. But yes, guys, that's something that we'll be looking into after a couple of more minutes. Maybe I might extend this workshop more than 10 o'clock, let's say for 10-15 more minutes. But yeah, I'll try my best to cover up everything within, the upcoming 50 minutes that we are having. I'm going to start the screen share. Just give me a second. All right. I've started my screen share. I'll close this part and I'll focus on this one. All right. So yes, guys, this is the same kind of animation that you had seen in your, the, what do you call this, PPT, that these values that are being changed are what? In every iterations or every iterations, you are changing the value of the coefficient, that is weight, along with the bias. So these values are getting changed, and how impactfully you can see that it's getting to the line of the best fit. This is something that you will be making by the end of the day. Okay, that's something that you'll be creating. All right. And you're going to do it completely from scratch. You're going to write each and every piece of code over here in order to achieve this. Let's see how we can do this. So the first part that you're seeing over here is to import some of the tools that are present in Python that's going to simplify your work. So that's what I'm doing over here. I'm simply running the first code cell over here. That's going to give me ability to, first of all, I'm going to use this particular library to visualize something. I'm going to use this pandas library to get some kind of tabular output, to get some kind of table output. I'm going to use NumPy to deal with some random numbers, because I told you, right, you need to have some kind of random numbers in this whole process. So that's why I'm going to use NumPy. Okay. So these are the 3 tools that are available in Python. That's going to save a lot of my time. I'm going to use this kind of tools. Okay. Now the first step over here is where I'm creating the data set. I'm going to explain each and every line, don't worry. So what am I doing? I'm trying to create a formula over here for the linear regression. That is y is equal to 2 times x plus 9. This is the formula that I want my model to predict. So what is my model predicting actually over here at the end of the training? The value of 2 and the value of 9. This is something that you're going to see. How do I know it? Because I'm creating a dummy data set to explain you these things. Because I am creating a dummy data set over here. I already know that there is one formula being used to create this data set, right? So in real life, what's going to happen? You are always going to have some kind of data from the data engineering team. Okay. But for now, to give you the essence of what you are actually doing, I'm creating a fake data over here, a complete fake data that's using some of the weight on top of the X data and also some kind of bias value. And you can see that I'm also adding some kind of noise to it. Now, what is this noise? Okay, what is this noise? This noise is something that you will understand right now. Let me just press this particular symbol in order to run this code cell. So because of the help of PLT, that is nothing but the matplotlib.pyplot, I'm able to create this kind of output. And the kind of problem statement that I have taken right now, and it's completely like, it's completely any kind of thing that you could have assumed. The one thing that I have taken over here is that the inputs, what are inputs? Inputs are your brightness of a star. Okay. And I am creating it by myself. How? I am using this kind of code. What is this code doing over here? It's going to create random numbers between 0 to 1. What it does, it creates random numbers. Okay. The reason I'm giving this kind of hash command is because I'm commenting something. I'm just adding some kind of description. This is not a code. That's why I'm giving this kind of hash. I'm creating random numbers in between 0 to 1. That's it. And then I'm multiplying it with 3 so that the range becomes 0 to 3 because of that multiplication of the 3. So this is the type of data that I'm creating, and it's a one-dimensional data. It's a one-dimensional data. And clearly you can see that on the x-axis, you are seeing that the values are going from 0 all the way up to 3, right? So this is the initial data, guys. Right now, I am having only one type of data, that is x. Okay, that is y is equals to only 1x. And because it's only 1x, I'm going to have one weight value and one bias value. That's it. And my job will be to get my model predict the optimal value of b and optimal value of w. That's it. But yes, this is how we are creating our x data. That is completely random, guys, completely random, but in between 0 to 1. But because of the 3, you're going to get the output in between 0 to 3. Okay. Now this y train, guys, this formula is used to create fake size of star based on the brightness. Whatever will be the brightness, let's say 0.5, for example, some ambiguous units. Based on that, what will be the output? And that output is nothing but the size of the star. This is the kind of problem that we are going to solve. If I give any kind of size as an input, the challenge of the model will be to get to the very closest possible to the actual value, whatever is the size. And that's what we'll be seeing by the end of the session, that yes, that's something that you have created by the end. Okay, it could be any x or y. Okay, it could be, let's say, for example, how much amount of hours you are going to practice this kind of thing that I've explained. And then what is the marks that you will be getting in your interview. Let's say this is the kind of model you are trying to train. Even that is fine. Okay, by just understanding how much amount of hours you will be spending on preparing for the interviews, this is going to give you the score of, like, how much amount of marks you will be scoring in your interview rounds. Okay, could be any kind of problem statement. I am just creating a fake data to explain you the internal part. Okay, but in real life, you will always have some kind of data, guys. Remember that. This is to just tell you an idea that, okay, the output of your linear regression should be 2 for your weight value, the W value, and very close to 9 should be the bias value. Okay. Now, what is the purpose of this random noise? Let's say if I remove this part and run this code, you will see that everything is falling into the straight line. But is your real data like this? No. So what I'm doing, I'm giving some kind of external values in the y value. Maybe some of the values is going up, For some values coming down, and for some values there is no change. It's staying in that original line itself. I'm allowing that by adding this kind of noise. Okay, and again, this noise value is in between 0 to 1. There are 100 different noise values in between 0 to 1. It could be 0, it can go up till 1. Okay, that's the value. So in between 0 to 3, I used my X to create my output Y with some kind of noise so that it tries to mimic a real type of data. Okay, and these are the bunch of code that I'm passing to adjust my figure size to look at the output. Let's say if I want to decrease the output size, I can just have it, let's say for example 4,4 over here, 4,4. And let's say if I'm running this now, it's much more smaller output, right? So that's what you do with the help of figure size. Okay, I'm just going to change it to whatever it was original. Then what kind of plot you want? I want a scatter plot. That's why you're getting this kind of random points over here without any kind of connections because of that scatter plot. Then I'm adding some kind of X label, Y label, and title with different type of font, different type of color. For the title, I'm using red color. I'm saying that the text weight should be bold. It's not for the Y label or the X label. There is no bold. There is just a magenta color that I'm giving because of this M. You can also write magenta over here. Even that is fine. Okay. And the font size is 13. You can try to change these values and see how it impacts your output, right? But yeah, this is the kind of graph that we have created that is depicting that, okay, this is the data that you're going to deal with. You're going to get line of best fit for this data by the end of this particular program. By the end of this program, whatever will be the line of best fit that will pass exactly from the middle, exactly from the middle. This is the kind of thing that you're going to get. Okay, guys. So yes, all of these things are part of comments. I can simply get rid of them. I can also, I can also get rid of this line because it's not important. And yes, now we are about to look into, because all of these numbers are random. If I have to show the output to you, I just need to run this code, which is going to print first 5 input values. And how you are giving it? The X train variable that you have used to create this training data, right? I am taking the first 5 values out of it. That's how you take the first 5 values. Similarly, from the Y train, the output that you have created with the help of this formula, 9 plus 2 times X train plus some kind of noise in between 0 to 1. The output of them, the first 5 respective outputs, is stored over here. And these are the outputs that you're looking like. So if the input of the model is 1.63, what should I multiply this with? And what should I add that with? That is weight and bias. So that I get very close output as compared to this. This is something that we are going to train over here, right? So to initialize some random value, like initially, you know, right, in the gradient descent, you want to start with some kind of initialization of weight and bias value. Trust me, guys, have any value over here. You will see that maybe it's taking some time for you to get to the optimal value. The closer you are, the less iterations it will take. The farther you are from the optimal value, more iterations it will take. So I'm just randomly choosing this as 0. Let's 0 because I've mentioned a comment. Initialize the weight and bias to 0 over here. I'm just going to have 0 over here. Okay, simple as that. You can try to have, let's say, for example, 0.5, 0.3, whatever values that you can think of, random values, because that's the main goal of machine learning algorithm. Get the optimal values, whatever it could be initially, as random as it could be. I have just chosen to be 0, 0 for now, literally right now. You, let's say, for example, choose this as 0.5, this as 0.3. It's fine. Choose any value you want. I have chosen 0, 0. After this, I'm deciding what is my learning rate. What is this learning rate? I hope you guys remember from the gradient descent formula, there was alpha, right? There was alpha. So because I know 0.01 is the starting value, it could be any value for you. It could be 0.001. It could be 0.00001. It's anything up to you. I am starting from the standard value that we use in machine learning, that is 0.01. The reason we call it as a hyperparameter is because we know we can change this parameter. We can change it and see how it is impacting the training. That's why we call it as a hyperparameter, right? So after initializing the random values to W and B, could be any value that I could have think of. Okay, I could have thought of. So it's 0, 0 in this case because that's the comment that is written over here. And learning rate, again, I am choosing a standard one that we start with, that is 0.01. Okay, so I'm going to run this code. So my W and B values are initialized, and I can also print it and see the output over here. Okay. You can see that the initial model parameters are indeed W0, B0. Okay. Whatever you are seeing over here is a part of formatting of the string. You are using this F string in order to get the actual value of W and B over here. If I, let's say, for example, change the value of W to 0.3 and I run this code, well, if you're wondering how am I able to run this code, I'm simply pressing Control plus Enter at the same time to run the code without pressing this. Okay. And now if I run this, it dynamically changes the value of 0.3, automatically changes it. Why? Because of this F string that I'm using over here. Whatever will be the value of W, it will automatically get used to it, or it will take that value. Okay. So I'm going to just set it back to 0 and set this to, like, just check if everything is fine. All right. So now we are done with few initial steps, that is to get the data set. In our case, we did not get it from our data engineers. Rather, we created a fake data set to appreciate the learning that we get by the end of the session. So the data set part is done. Initializing the model parameter is done. Hyperparameter is done. Now what is left? You are left to code the forward propagation equations and the backward propagation equations. But before I go any further, any kind of doubts, guys? Any kind of doubts so far? Please let me know if you're having any kind of doubts. Any doubts in understanding why did we create a fake data set? If yes, the answer is just to understand how the linear regression is working. If you don't create this kind of fake data set, you will not be able to appreciate it. And if you don't trust me, wait till the end of this particular workshop. You will be able to understand it. Okay. And the second type of doubt you might have is, maybe I'm not able to understand why did you use this F. This type of doubt will obviously be solved once you know how to use Python. Okay. For now, just try to observe it. If you're not able to catch up with the syntax, syntax is fine. Syntax takes just 1 minute to master it, literally 1 minute. You just need to know, okay, this kind of syntax exists, and then you know this kind of things exist and you start using it. Simple. Okay. So till now, what have we done? We created this kind of a fake data set so that we are able to understand why did we choose that 2 and 9 over here. Your model will be able to predict this 2 and 9 automatically. If you change this value to, let's say, 10 and let's say -2, even that will be able to be predicted by the model by just running your whole code. By clicking on runtime and click on run all, you just change these two things. You will see that your model is able to even predict that automatically without changing anything in your code. And that's the beauty of linear regression, guys. Okay. Or I should say machine learning. Now, coming to the next part, that is to compute these two equations for the forward propagation. How would you make the predictions if you have the input value of the brightness? Just take this M as W, take this C as bias. Okay, M stands for weight and C stands for bias. Okay, so if you're having this X and the initial values of M, that is weight and bias, how do you get the prediction value? Let's try to compute that first. So I'm going to use a method in, I should say, I'm going to use a function in Python. This is how you define a function. The whole purpose of function is to reuse it again and again. If I just pass in some different value of X, some different value of W, some different value of B, it's still going to give me some kind of prediction. I just need to pass in the inputs. It's going to do all the calculations automatically because of the function. How it works? You need to say what is the function you want to define. What is the name you want to give to it? I can give any name. I can give LOL if I want. Okay, I can give anything. But we name it sensibly so that we understand why did we create this function. That is to make some kind of predictions, right? So let me just use this predict, and it takes certain kind of inputs. We know that prediction is dependent on bias value, weight value, and the brightness value. So all of these things I'm going to pass in the input, and it's going to give me as an output the predicted value. Okay, so now what you have to do is you just take the pass value, just delete that part and type return. What does this return indicate? It indicates that it's going to give you some kind of output. Okay, but what output exactly? It is going to be the multiplications of your weight with your W, I mean weight with your input plus bias, right? That's how this works. Y prediction. What is your Y prediction? It is actually X input into weight, W into X plus B, right? I can also write this as W into X, even that is fine. Multiplication order is not really important, right? So yes, this is our first function that we have created, that how you can make predictions. Just pass in the values of X, W, and B. You call this function and it's going to give you some kind of output. Let me just copy this whole part over here and paste it over here and run this code and show it to you how it's going to work. I'm going to pass in, let's say, some value of, I'm going to call this predict function. I'm going to pass in X value, let's say 10. I'm going to pass my W value as 0, B value as 0. And if I'm going to run this code, it's going to give me output of 0. Why? Because that's the prediction. X, it was 10, W was 0, B was 0. So 0 into 10 plus 0 will be 0. So you can see that the output is working fine. So yeah, that's how you can test your function if you want. But yeah, that's what we have done over here. We have created a mechanism, a function that's going to help you predict the output if you pass in input, weight, and bias value. The second thing is to develop a cost function or a loss function. And clearly, because we are using the mean squared error, how we are going to compute it? This is where a logical kind of part kicks in. Okay, how you think logically to get this thing done. One developer to other, this method can vary. It's completely fine. Being a beginner, you can implement any kind of method that's going to work best for you. Okay, don't even think about how you can optimize your code as of now, being a beginner. Okay, so I'm going to show you one approach through which you can achieve this. Okay, the main goal over here would be create a variable that's going to store different values of loss, different values of y minus y prediction square. Okay, after that, what I'm going to do is I'm going to sum it up, sum all these values. Okay, after summing up all these values, I need to take mean of that sum. So these are the kind of steps that I'm going to follow, right? So clearly we can see that over here, we need to have this kind of difference in actual value and the predicted value. So how can I get this done? So I'm having my output, clearly this y is nothing but my actual output, right? So my minus y minus the predicted value, predict of this x value, w value, and b value. Why am I writing predict x, w, and b? Because that's how this function works. It takes x value, w, and b value in the same order. So in that same order, I need to pass it over here. So this is going to give you what? This is going to give you this kind of part, this part. Now you need to square it. So you go ahead and square that part. You take this inside a bracket. You do this double star. It basically means you're raising it to a power, and that is 2 in our case. Right? Now this is going to do it for only one value. If you see, for only one value, it's going to take some kind of y and make some kind of predictions on top of that, and then you square this error. But how can I create a mechanism through which it goes through each and every value of x, each and every respective value of y, and get respective predictions done, and then you sum it up together? Because I want to go through each and every value of x, one of the ways through which you can do it is with the help of for loop. Is it the optimal way? Again, the answer is no. You can use numpy arrays to do it very optimally. And just because I don't really want to introduce a lot of new things to you, I am just sticking with the basic things. And therefore, I'm going to use the for loop. What am I going to say? For each and every value of the inputs that I'm going to get, for every inputs that I'm going to get, I want to do this kind of process. So how I make this work is something that I need to figure out. So for I in range of total possible values that I'm having, let's say n. But what is this n? I haven't defined this n, right? I'm going to define it over here on the top. N is equal to what? Because we are choosing 100 values over here, we are choosing 100 random values as an input. This value will be 100. There are total of 100 rows of data that I am creating, and therefore this n needs to be 100. But how can I do it dynamically, automatically? I just need to use this function called len on top of this x. because this X is nothing but the whole 100 values that you have created. Okay. These are all the inputs, not just one input. This is total 100 inputs that you have created. So for each and every value that you will be having inside that X, you want to get an excess of that. I can do this with the help of this for loop. And I need to implement this formula on top of that. Okay. So what is this formula? Let us just try to have it over here. It's going to take the respective Y value. Again, remember, this Y is bunch of different values, not just single value. But now the one that is present on any particular index over here, you're going to get access of that particular Y. Similarly, in this predict function, you are going to pass only one value of X, that is with respect to I. So what does that mean? Let me explain you over here. I have already created my X string, right? I've already created my X string right over here. How can I get access to the first value that I am having over here? I just need to, let's say, write 0. It's going to give me this particular value. If I want the second value, I need to change it to 1 to get the second value in the input. Okay, it's going to be 0.835. Okay, so using this kind of index, you can get access to all the values one by one, starting from 0 all the way up to 99. Okay, the 99th value is this 1.9729. That's the last value that you're having in the input. Let's say if I say 100, what's going to happen? It's going to throw an error. There is no value present on index 100 because 0 to 99 is already 100 values that you have taken into account. So yeah, that's exactly what we are doing over here with the help of this I. This I is going to go in between 0 to 99. So for every value of that I from 0 to 99, I'm going to get my respective value of the Y, the respective value of X, do this kind of summations, do this kind of error and square it. But then how am I going to sum it up to my previous value? For that, I am going to create one variable to store this kind of losses. I'm going to call it as, let's say, total error. Total error. Let's say this is 0. Initially it is 0. Now I'm going to add this value to this specific 0. And every time this loop is going to run, every time this new value of Y will come, new value of predict will come, I want to add the outputs to this 0 or whatever was the previous value. So how can I achieve this? I can say that whatever was my previous total error, I want to add this new value on top of that, and I need to save it again into the total error. Total error. Okay. Don't really worry about the syntax, guys. Why there is this colon over here? Why there are these spaces over here? This is how your Python works. This is how your Python works. This is the syntax. Don't worry about the syntax. It's very easy to master it. That's my promise. Okay. But yeah, for now, just try to understand this. Because I want to repeat the steps for n times, that is, your I will go from 0 to 99. For 99 times, it's going to calculate the square of your error for every rows. It's going to add to the previous value of the error, whatever it would be. In the next update, when the I value will go from 0 to 1, it's going to update this value of total error from whatever would be the next value to the next value. Like this, I'm going to ensure that every time my total error will keep on adding depending on the next value of this sum of the error square. Whatever is the error square, I'm just going to add it to the previous value of the total error. Starting it was 0. After first iteration, it will be some new value because of this. Some new value will be there. For example, let's say 1 is the new value you are getting. In the second run, this total error will have a value of 1 because of that updation. Now, on top of that 1, it's going to calculate another error. It's going to add you on top of that 1. Let's you get, for example, 2, like this. So that's how you're going to sum up all the errors. Okay, so yeah, that's the kind of code that I've written for that. And a quicker way to implement this would be to use what kind of operator? Use, I forgot the name. You call it as an increment operator. Increment operator. How it works? If you want to add something to the previous value, and if you want to save your time, you can simply cut this part and simply add a plus over here. Even that is fine. Even the previous version is fine. Even this is fine. This is a better way of coding. You are taking the previous value of total error, adding next value that is present over here. Simple as that. Okay, you can either choose this way of writing, or I can go back to this kind of error. I mean, this kind of format. Even this is fine. There is no problem with this also. Okay, but yeah, I'm going back to this way through which you should learn how to code in Python. Okay, a Pythonic way of writing this is this. Okay, now let's try to understand what is happening inside the cost function. It's going to get me the total length of the input values, that is 100 in our case. It's going to start with some total error equal to 0. Then for every input in my data and the every respective output, I'm going to get the error which I'm squaring, and then I'm adding it to the previous value of total error. So it's going to start from 0 and keep on adding up to the value that we can go up to. Okay, so that's how this function is working. And what should I return? What should I return over here? I need to take the mean of these values, right? I need to take mean of these values. So what I do is I'm going to return the mean of this, the total error that I'm going to get after summing up. I'm going to simply divide this by n, simple as that. So my function is complete. I may run up to some kind of errors, but it's completely fine. Okay, so I'm going to run this. I'm going to go ahead and check. I'm going to test this particular function by simply running this code that I was having in my original notebook. Okay, you must be getting this kind of code in your notebook as well. Just make sure that you are running this code. Okay, just make sure that you have run this code successfully, and then you try this. You're going to get some kind of an output like 150.0445. If you have used a different value of W and B, if you have used a different value of W and B, you might get a different value. It's completely fine. You must get an output over here. There should not be any kind of error. Okay, so for everyone to be on the same page, I'm just going to copy this whole code of the function and pass it over here. Okay, yes guys, you can copy paste it directly over here. It's completely fine. But now there is one problem. Okay, there is one problem, that I'm not getting 150 directly out. I'm not getting 150 directly out. So what I'm going to do is I'm going to come over here and just pass this kind of parenthesis and get the first value out of this array. So I can do this with the help of 0 index. Okay, so I can just go ahead and run this code again. You can run this second code over here. And now what's going to happen, you will see that the output that we'll be getting is directly 150 without having any kind of array written on front of them. Okay, this is something that I really wanted to be the part of the output. What I did, I went back to the coding part. I am simply taking out the first value that is present on 0th index. Okay, so yeah, that's how you get it. So yeah, that's how you're going to create your cost function, and that's how you're going to also test it up over here. What have I done? I took the same kind of formulas you are seeing over here, converted into a Python code. So next time, if I give any kind of inputs with the respective outputs with some W and B value, it's capable enough to get me the mean squared error of these values. It's going to do it automatically now. That's the power of building this kind of functions. And it's completely fine if any one of you is not able to understand the coding part. Just in terms of revision, you can take all of these things that, yeah, this function is going to contribute to get the loss function. Okay, if this loss is very high, not very close to 0, very high value like 150 for example, it's a bad model. 0 is a bad value. Okay, I want my W value to go to 2, I want my B value to go to 9. Currently, because it's 0, you can see there is a high error. Okay, but yeah, this is how the cost function is developed. Okay, now the second thing that I'm going to do is to create the last type of code that is very heavy. Apart from all of this, everything will be very easier for you to digest because there is not a lot of coding part involved. This is the most part that you are seeing over here. This is the most difficult part that you have coded. Everything will be either similar to this or maybe less difficult. But yes, if you have understood this part, understanding everything else will be a piece of cake. Okay, the only logic that we are implementing over here is that how we are going to sum up the values. If we have sum of y and the prediction, how do you keep on summing up on all the possible values in the data? I'm doing with the help of a for loop. I'm creating a variable to store all the losses that I'm getting over here and keep on adding on top of that. Okay. And yeah, that's the kind of output that I'm going to receive at the end. All right. And I've also tested my function. It's always good to test your functions before you use it in the final training. Okay. That's how you test it. Okay. So because it's not giving me any kind of errors, I'm good to go. I'm just going to check the chat section if you're having any kind of doubts. Yes, guys. Great. I can clearly see that right now there are 9 people that are available. I'm expecting there should be at least one by the end of the session. Okay, guys. But yeah, let me just continue ahead from this particular part. I'm going to create a code. I'm going to create a code that's going to ensure the derivatives of cost function with respect to weight, the derivative of the cost function with respect to your bias. Remember, this m is nothing but your weight. This c is nothing but your bias value. So this is the equation that I was talking about, that if you are aware about the partial derivative of this function, then you will be able to get this specific output. But let's say that we don't go into the mathematics part and assume that you already are having this kind of equation. How do you implement the gradient descent part? How do you implement this part? This is one last thing that you are coding, and your training is going to work just smooth. Okay. How do you update your model parameters for weight and bias? That's only what you have to think now. The same kind of logic we can implement over here that we have used above. Okay. Because in the update weights, we are going to use gradient descent that's going to use the value of this learning rate. I'm also passing in the input as a learning rate. Apart from the X, Y, W, and B, I'm also passing in the learning rate. Okay. Now what's going to happen over here? What's going to happen over here? I'm going to code all of these things you are seeing over here. The important part is that how do I update the value of W and how do I update the value of B? I will be able to do it with the help of what? Gradient descent. The previous value of W minus learning rate into what? Into the derivative part. But I have not calculated the derivative anywhere. But let me just call dW to be that derivative term over here for the loss, I mean for the weight. And in the same way, I'm going to create this for bias minus learning rate into dB. This dB is nothing but the partial derivative of cost function with respect to this B. Okay. But now you need to understand how you can create these values of dW and dB. How you can create these values of dW and dB. And as you can see, this formula is very similar to this. Implementation is just the same. You take the same concept that you have learned over here. You take one variable that's going to keep on summing up the stuff so that you can take the average later on. Then whatever is the thing that you want to create, that is the difference of the two things, square it and then sum it up together. The similar thing you are seeing over here. Instead of just taking the difference, you're also multiplying this with minus 2 times the input value. And then you're summing up this kind of values and then taking an average of that. So let's see how we can create this kind of a code for this DLDM and DLDC. In our case, this DLDM is nothing but the rate of change of loss with respect to your weight, and this is with respect to your bias. Let's try to code it up. So what do I need over here? I'll be requiring a for loop, right? I'll be requiring a for loop for I in range of again n. But now what is n? I need to define that n again. So n is again the length of that x. That's going to be 100. And what do I need to do? I need to update the values of dw. But what is the formula? It is minus 2 times the input value times this kind of difference. So I'm going to say that minus 2 times x value of the current index multiplied by what? Multiplied by the difference of the actual value, that is your y current, minus the prediction of your on the basis of your x current, w and b. Make sure it's always in that same order. It should be in the format of x, w and b, guys. Okay, so that's exactly what I've passed over here, x, w and b. So what I'm having, I'm done with this part, guys. Minus 2 times x into the difference of actual y and the prediction of y, right? So yeah, the formula is computed. I just need to store this in some kind of dw is equal to 0. Okay, d capital W is equal to 0. And similarly, I'll also do it for db. db is also 0. I'm going to store all this value inside that, right? So I'm going to say that this is dw plus equal to this. Whatever was the previous value, you add new value on top of that in one loop. And I'll just copy this exact line and paste it after pressing enter over here, and just convert this to dB. And what is the formula? Let's check the formula. The formula over here is very same, just that x is missing. So I'm just going to get rid of this x. Simple as that. I'm having -2 into this difference. That's it. And I'm keep on adding onto this dB value. Simple as that. Okay. This is how I'm going to ensure that once this loop is over, I'm going to get all the possible values of summation of these items. I haven't taken any kind of average. I didn't divide this by n because I'm about to do it in the next step, that is over here. Whatever is the dw value, I'm going to divide this by n. Whatever is the db value, I'm going to divide this by n. Because I cannot do it over here. I cannot do it over here. Why? Because this is simply adding these values to the previous value. I am not taking any average. I can take the average once the summation part is done. So this part of code is ensuring that the summation is done. Okay. I can also write a comment over here. This part ensures the summation is done. All right. And yeah, simple as that. After this summation will be done, after that you implement gradient descent. Implement gradient descent. Okay. Where the formula is just like this. And again, if you want to optimize it, you can use decrement operator. Just like how we are adding the previous value to this new value, if you want to subtract it, you just use minus equal to, and you just get rid of this and this minus also, and you are fine. You take this bn minus and just have minus equal to, it's going to do the same thing. Okay, it's going to have the same thing. W is equal to W minus learning rate into dw by n. Similarly over here, b is equal to b minus learning rate multiplied by db by n. The reason you are seeing this divided by n over here is because of the reason I am dividing my this total summation part with the n. That's the reason why I'm having n over here. Okay. Now, what are the things I need to give as a part of the output? I need to return the new value of w and the new value of b. This is something that I want to return. After this step was done, whatever was the previous value of w and b that I was getting as an input, this function is going to give you the new value. Okay, this function is simply going to give you the new value. All right. So this part of code is ensuring that these two things are calculated, and this part of code is going to implement gradient descent with the help of this derivative terms that you have created. Don't worry about this formula, guys. Okay, it's not that important that you should know how to derive it. Okay, but yeah, this is how you're going to get these things done. I'm going to run this code, and hopefully I won't be getting any kind of errors over here. But yeah, you can always go ahead and try to test this code on some of your X data, some of your Y data, W and B. So what I'm going to do is I'm also going to test it over here only so that I don't face any errors later on. So X values will be, let's say, X train, the first 5 values of X train. Y value is nothing but Y train, the first 5 values of the Y train. W is, I know, is 0, B is 0. Learning rate is also defined. Where have I defined it? I have defined it at the top over here. W and B is defined. Learning rate is also defined. Right? X train and Y train is what? X train and Y train is something over here. Right? X train and Y train. This is something that you have coded over here. All right. Now, if I go ahead and run this part of code, hopefully no errors. If there are any errors, we'll fix it. Okay, we are having an error. that local variable dw reference before the assignment. It basically means over here I just need to pass this as d capital W. Okay, there is nothing like dw over here. It's d capital W. This is what we have assigned a value, and therefore we got that error. So I'm going to say it's d capital W and run this code. And now I run this update weights. Now I'm having some values 0.331505, and for this it's 0.24299. It means I'm getting some kind of value. But now again I need to fetch it out. So I'm just going to give this 0 and 0 over here and run this code, and then again run this code. Yes, now I'm having the values without any kind of brackets. The reason you are getting it one bracket is because there are two outputs that your code is going to give you. One is W value and one is B value. Python automatically gives you in the format of this kind of brackets for that reason. But this is my W value. This is my new B value. Okay. This is my new B value. This is my new W value. All right. So yeah, our function is working just fine. Okay. Testing of update weights. Let me see if there is any doubts over here. No doubts? Good. Obviously, I'm 100% sure not everyone will be able to understand everything, but still, because you are over here, it's really great that you are trying to at least understand something. Okay, I appreciate that part. Yes, guys, now we are done with the complex kind of part of code that you must have seen over here. There is nothing more complex than this. That's something that I am promising you. Okay, there is nothing more complex on top of this. This is the most difficult kind of code that you have done. Everything else you will see that I have already coded for you. If you have done something like this till now, you should actually praise yourself. Okay, just pat yourself on your back that you have done a good job from my end. Okay, I'm giving you this kind of pat. All right, guys, because coding this kind of thing for the first time takes guts. Just think about it. There were 30 people at the start. Currently there are only 6. Okay, the reason you are seeing 8 over here is because that's one me, and the one that is sharing the screen, that's myself again. It's just 6 of you over here. That's something that's really good, guys. But yeah, now what I'm going to do over here is I'm going to go one step further and create a function for training purpose. What is this function going to do? What is this function going to do? This is where training is going to happen, guys. Okay, every update once I get, I need to connect these two things, right? I need to connect my cost function with my update weights, right? Until I don't connect these two things, how will my training happen? I need to have some of the way of mechanics through which I can make these two things work. Cost function in parallel with the update weights. So for that, what I have done, I have created one more function called as train. Over here, indeed, guys, I'll be taking further few more minutes before I can go up to the roadmap part. But surely it's going to be something that you're learning, and it will be worth, it will put you 100 times farther as compared to the people who doesn't know what I'm teaching right now. Trust me when I'm saying this. It's going to help you very well, super well, when it comes to interviews. Super duper helpful. That's my promise. Okay. But yeah, I'm going to take extra few more minutes over here to explain this part. So what's happening over here, guys? In this training loop, I need to store all the new values of weight and bias that I'll be getting because of my update weight function. Because I know that whenever I'll be calling this function on some values of X and Y and for different W and B, it's always going to give me one W and one B as an output. I know this. So how can I save it? So for that, I have created this kind of list in Python. Currently, I'm passing in the original values of W and B, that is 0, 0 in our case, right? Both of them are 0, 0 originally. But now I'm also creating a list for storing the cost. That how after every epoch your cost is going to decrease. In the start, it's going to be very high. Why? Because the W and the B value is not optimal. But the moment the values will be optimal, you will say that the cost is decreasing. But how you will be able to visualize if you are not storing this kind of values? So for the storing purpose, guys, I'm creating this kind of list. For W and B, because I already have some initial values, I'm already storing that as the first value in this weights and bias. All the new values will be added after this. Okay, let's say for example, w after first iteration, w after the second iteration, so on and so forth. Same for like b after the first iteration, b after the second iteration, so on and so forth, and same goes for the cost. But it's going to happen automatically. Okay, how? Let's understand. So what I'm doing over here, I am creating a never ending loop. What am I doing? I am creating a never ending loop that's never going to end until the training is over. Until the training is over, this loop will keep on repeating itself. The way I can do this is by calling that until this loop is true, you keep on running this loop. And once this kind of break statement is correct, you terminate the loop. That's where you're going to end the training process. So how do you end the training process? That's something that I want to explain over here. Let me take 2 minutes to explain it over here. Okay, so how do we end this kind of process over here? Simple things, guys, very simple things. Over here, I am going to store the values of the cost in this list, right? So let's say I'm having first cost value. After running this training loop, I'm having one cost value as 2.022322, something like this. Okay, now the next time I'm going to run the loop, I'm going to get a second value of the cost, right? Because in the loop, you can see that I'm trying to calculate the cost by calling the cost function that we had created earlier, right? Over here, if I'm calling it twice, it's going to give me two values. So once I'm having two values, and let's say the second value now is a value that is not very close to this. Let's say it's 2.535214, some random values. Okay. But after this, let's say the third time this is going to run. Okay, let's not say 2.5, let's say 2.00 something 214. Okay, so the third time this cost will be there, will be very close to the previous value. Why? Because the updation is stopped now. Updation is not happening. So what I'm going to do is, if I'm creating this kind of a list, I want to take the last two values. I want to take the last two values. I want to check the difference between them. What is the difference between them? And if the difference is below a certain value, a threshold value, a tolerance value, you will say that your training is over. Let's say correct to 13 decimal places. Correct to 13 decimal places. These values are exactly the same. But after the 13th decimal place, let's say you're having some extra values. That is fine. But for the first 13 decimal places, I want it to be accurate. So how can I do this? I'm going to explain that part. First of all, let's say that this is my cost dummy. This is the kind of list that I've created. Okay, now what I'm going to do on top of this, I'm going to say that cost dummy of -1. So what is that -1 going to return? It's going to return the last value that I'm having. Now what is the -2 going to return over here? -2 is going to give me the second last value in the list. Now what I'm going to do is, I'm going to get the excess of the cost dummy -2 minus the cost dummy -1. But I'm going to take absolute value of this so that the negative issue is not there, right? I'm going to take the absolute value of this. And if I run this code, if it's below any kind of threshold value, what am I going to say? I'm going to terminate the training process. I'm going to say that my learning is optimal because there is no updation of cost. Correct to 13 decimal places, guys. Imagine 13 decimal place means what? 13 of the decimal values are just the same in the previous cost value and the current cost value. 13 decimal places are same. So if that is the condition, I want to break my loop because now I am sure that my model has reached the optimal values of weight and bias, W and B. So this is something that I'm going to implement in my code. Okay. And initially you can see that I initialized my empty lists for cost and one value of the weight and bias that we already have, that is 0, 0 in our condition. I'm also going to have a counter. Okay, you will understand what is the reason behind that. That's going to keep a count of how many iterations we are doing. Okay, for one loop, I will be 1. For the second loop, the I value will change to 2. For the third loop, I will be changing to 3. So how many total iterations it's taking in training before it hits the break condition? That's what I'm calculating with help of this I. Starting from 0, the first step I'm doing is to pass in the training values of X and Y. pass in the actual W and B values, that is 0, 0 in our case, and get the cost value. Whatever is the cost value, I need to store it in this empty list. How am I doing this? I'm using this append function on top of this cost. And yeah, that's exactly how you are storing it over here. Okay. So once you are storing it over here, what's going to happen? It's going to run this if condition. What is the condition? I need to write it over here. So the condition is if at least there is one value in the cost function, at least one value in the cost function. So it is only possible if the value of I is greater than or equal to 1. So I'm going to say that if I is greater than or equal to 1, at the same time, I'm also going to check the absolute value of this cost. If that absolute value of the, like, last two values I want to grab, right? So -1 minus cost of -2. So the last value minus the second last value in the cost list. If the difference between them is less than a tolerance value, what is the tolerance value? I have already given some kind of a predefined value, that is 10 to the power of -13. So you can try to change this kind of tolerance value. The lesser the tolerance value, less accurate your model will be. Okay, I mean, larger the tolerance value, less accurate your model will be. And lesser the tolerance value, more accurate your model is. My model currently is 13 decimal places accurate. Okay, so that's what I'm doing over here. I'm taking the last two values from the cost, and it's going to throw an error if I'm not using this condition. That is, if the value of I is 0, there is no value that is present inside it. Right? There is no value. But when the value of I will become 1, I'll be having at least one value. Right? And once I'm having that 0 and 1 value, I can simply go ahead, take the difference of this, and if it's less than the tolerance value, I'm going to break the loop. I'm going to say that my training is done. But let's say if this does not happen, if this value is very high and it's not below this tolerance value, I start the training process. I'm going to update the weight. I'm going to pass the X value, Y value, WB learning rate in the same way where I've defined over here. In the same way, it's going to go into the input. And yeah, your W and B will be updated. Once your W and B are updated, guys, once you are having the new values of W and B, the second time this loop is going to run, will take the new value of W, the new value of B. The new value is nothing but the one that you got over here. In the second loop, it's no more 0, 0. It's the value that you're getting as an output from this update weights function. Once you get the output, you also want to store it, right? You want to store these values. So what you are doing? You are simply appending these values to this list. So after first iteration, it will tell you a new value of W, a new value of B in this list. So like this, your loop is going to go ahead. And after every 100 iterations, I'm printing the history. After 100 iterations, I'm going to check what is the value of iteration, what is the value of weight after 100 iteration, what is the value of bias after 100 iteration, and what is the value of cost after 100 iterations. This is what is done with the help of this line of code. And then what am I doing? I am just increasing the value of iteration to 1. From 0, it's going to be 1. Again, see how am I using the this increment operator. Previous value was 0, so the next value will be I. So yes, guys, that's how this kind of loop is going to go through. Okay, iterations by iterations. This is what we call one epoch. Okay, this one loop is called one epoch. So epoch by epoch, your training is going to work like this. And the moment when this happens, automatically you will see that your loop is going to be terminated. That's where your training is going to be over. Right? So I'm going to run this code over here. And we are done, guys. Every coding that you had to do is done. Now you simply go ahead and run the training loop. I'm going to run this code. I'm going to pass in the actual values of X, Y train, W, B, learning rate, and verbose. What is the meaning of this verbose? If verbose is going to be true, at the same time, if this index value, if the iteration value is a multiple of 100, only then it's going to print this history, or else it's not going to print the history. Okay, I guess there is some kind of an error. Let's try to check it. It's saying that invalid index to the scalar variable. So there is some kind of a problem in this if condition. Let's try to fix that. So what is the problem that we are facing over here is something that we need to understand over here. Okay. So what I need to do is I need to maybe try this greater than 1. Let's see if it's working fine or not. Okay, it's again raising that error. It's raising exactly at this point only. That is your if I is greater than 1 and the absolute value of this is below the tolerance, it's going to break. So see guys, this is the kind of problem that you will face whenever you are coding from scratch. Okay. And the best thing is that how you decode this code, how you are going to decode this specific code. Okay. So what I am going to do over here is that I'm not really going to show you how you are going to decode this. Rather, what I'm going to do is I'm just going to take this code. Okay. I'm going to take this code and paste it over here. But the important thing is that you need to understand how to solve this error. Okay. Whatever kind of error it was. I'm just going to retrain this part and see if there is any kind of problem that is getting solved. If not, it means there is a problem in some other places. Okay. There is some problem over here is with respect to this thing. Okay. Yeah. Don't get confused. Okay. This is some typical things that you will experience once you are coding everything from scratch. So the training has started. The reason that we were getting error over here is it might be because of some kind of typo that I might have done, but because we are running already out of time, I am not spending any time in this. What I'm going to do is I'm going to copy this whole code and paste it in the chat. Okay. It came only till count. No problem. I'm just going to copy that part also. But don't worry, I'm going to give you the whole file over here. So don't worry about that. But yeah, just for people who are coding along with me. This is the continuation part. Okay. This is the continuation part. All right, guys. So yeah, once this kind of training is done, see guys, how after every 100 epochs, how after every 100 iterations, the value of weights, you are getting some kind of output. The value of bias, you are getting some kind of output. The value of cost, you are getting some kind of output. Just see how it's going to decrease with time. Over here, you can see that the value of W is going closer to 2. The value of bias is going closer to 9, and the value of cost is very close to 0. Right? But because correct to 13 decimal places, there was no improvement seen. My model chopped off the training. It broke the training loop over here, guys. That's something you need to keep in mind. The way that we have coded this function is in a way that epoch by epoch it's going to do the training. And the moment the difference between this last two cost values is falling below the tolerance value, that is 10 to the power of minus 13 in our case, only in that case you are going to break your loop. Everything else will keep on training until that particular break condition has been hit. Right? So yeah, this is the output that we are getting. And after this, the code that you are seeing over here is going to create a table for you. So what is the table? Let's try to look into that. So this table is going to give you the comparison of the weight value, bias value, and the cost value after total training is done. Okay. We can see that how the weight value has started from 0 is now very close to 2. The bias value started from 0, but now it's not close to 9. Why? Because there was some kind of noise that was present. So your model is able to adapt that noise, because of which it's not close to 9, but a different value other than 9. It's closer to 9.5. So it is all because of the noise that we were having in the data. It's not exactly able to predict 9, but 9.5 because of the noise. Okay. And the initial value of cost was 155 point something. And the final cost, we are able to reduce it to 0.082279. That's the power of this machine learning model that you have created right now by yourself. Okay. Now I'm just going to run the next few codes that's going to help you visualize it. I'm giving some kind of title, X label, Y label, and I'm plotting this graph that is with respect to epoch. What are some different mean squared error values that I was getting, the different cost values that I'm getting? You can clearly see that my values are starting to drop to very close to 0. within the 500 epochs only. But then why are training kept on till more than 3000 iterations? The reason behind that is the accuracy. The accuracy that you wanted was correct to 13 decimal places, right? So because of that reason, it's going beyond 3000 also. Even though there is a very small update, but still there are updates. Until and unless the cost function is correct to 13 decimal places, it's going to run your iterations. And the last value of iteration was 3248. This much amount of the loop was ran. After that, 13 decimal place accuracy was achieved. All right, guys. Now I'm going to create the test data in the same way how I was creating earlier. Okay, this is the same bunch of test data that I've created in order to predict that on an unseen data. This is the new 10 values that I'm getting. Okay, new 10 values in between 0 to 1, and this is this is the true y values, true output values that we will get. Okay, and this is where our model is predicting something. Our model is able to predict something by passing the 10 values that we have created for the X test, the last value of the weight and the last value of the bias. This -1 means the last value in the weights and the biases list, right? So if I just go ahead and run this code, weights is equal to what? It's bunch of these different values. So I want to get the last value. So with the help of that -1, I will be able to fetch out the last value after the training was done. Okay. So what I'm going to do now is I'm just going to call this last value of weights and bias over here and get the predicted values. Okay. I'm going to run this code and you will see that these were the input values in between 0 to 3, a random, completely random values. This was the actual output based on this input. And this is what our model is predicting. Why am I saying that this is what is model predicting? Because we are passing the weight value and the bias value. And because it is very accurate, that is correct to 13 decimal places. This value of W, that is last in my training, and the value of bias, that is last in my training, I'm using them to calculate the output. See, original value was 10.8, but now your model is predicting 10.9. So if the brightness of a star was this was the actual size, but your model is able to predict very close value as compared to what is true value, right? Same goes for the different bunch of 10 values you are having, and you can clearly see that it's performing really well, right? It's performing really well. Now, how do you measure how well your model is performing? You simply create a mean squared error. How do you create it? You get the error of the y test and the prediction. You get the error of this in form of mean squared error. So how does this work? I want to calculate the difference between my y test and the prediction. Y test and the prediction. Okay. Is anything else that I need to take care of? No. Y test and prediction is good. I need to take the square of this. And then I take mean squared error. I need to take the mean of this. So np.mean is going to help me get the mean. Or else you can simply divide these values by the total number of length of y test and prediction. Because it's 10, it's going to be 10. And then if I look at the output of the mean squared error correct to 5 decimal place, I am getting 0.0123. Isn't it just good? So much less error, mean square error that we are getting on the test data. This is the power of machine learning, guys. Now you change the values of because all of this is completely random, you might need to train this for a little longer. You change these values of this 9 and 2. You try to change this to let's say something else. And same goes for this 2. And run all the code cells till this point. You will see that it's still performing well. The outputs will be different in this case. The W and B value will be different in this case, but the predictions will be very accurate. That's the power of machine learning, guys. This is what you have explored in this 3 hours of session, and probably beyond 3 hours we have taken. It's already 15 more minutes. But yeah, it's completely fine because you are learning some kind of skill. It's completely fine. Okay, we are done. We are done. I'm just trying to create some kind of comparative version of, see, this kind of stars is the actual value that your model is, sorry, not model, but your actual output of y test. This y test, this actual values, where it will be with the noise that is present in the data. It's going to be like this. This black line that you are seeing on top of this is the predicted line, guys. This is the predicted line. This is where my model is predicting that instead of over here, my model is predicting it's over here. For this, it's very close. For this, it's very close. For this two also, it's close. For all of them, it's close, except this particular value. It's fine. For one value, it's fine, right? But this is the kind of thing that you have developed completely based on random data, guys. It was completely random, and still you are able to get this level of accuracy, right? Now, every codes beyond this is not really important. It's doing exactly the same thing, but by a tool using sklearn library. Okay, so what I'm going to do is I'm simply going to press over here, run everything after this. So it's going to run all the code. So it's going to do the exact same thing. It's just going to use this one line of code, linear regression. It's done. It's doing all the same things that you have done above, but keep one thing in mind. We have used gradient descent. We have used gradient descent as an optimization algorithm. They are not using gradient descent. sklearn is implementing a different method to get the line of the best fit. It's completely fine. We are going to test our model with the sklearn model. Let's see how close would we get. Okay. So with the help of dot fit, it does the training process. And after the training is completed, this is the output of sklearn. And this is the output of the scratch model that we have created. Just see how close we have got. How close we have got. Just check that. Right. That's the power of coding everything from scratch and understanding what's going on. Okay. And I'm also going to get this kind of predictions, and the mean squared error on the test data is just the same, correct to 5 decimal place for the sklearn model and even in my model. So you are able to create this kind of code over here that is very close to sklearn. But is my model better than sklearn? How can I check it? I just need to increase the rounding of value to, let's say, for example, 10, and this is also to 10. Now any output that is less in value is performing better. Okay, so if I'm just going to run the code, you can see that which one is lesser. This value is clearly lesser. Right over here you can see that it's 2, and over here it's 4. So yes, sklearn indeed overall it's performing better than our model that we have created right now, right? But check the power, how close we are able to get to it, right? You can still modify this kind of training with a lot of different things that you can implement, which I have not even shown over here. But yes, guys, that's the power that I wanted to show you, that in this workshop, you have understood a whole idea of what is a machine learning, AI, deep learning, what is linear regression in terms of mathematics, in terms of coding, and you are able to compare it with one of the model that is you can create in just one line of code. Now, this kind of tools you are going to use in your actual job, this one line of code. But at times, what's going to happen in your job, this kind of already created model is not performing well. So as a machine learning engineer, you should be able to create your own code from scratch. It's created in a way that it's suiting your need and it's able to perform even better than what this kind of pre-trained, I mean, already existing architectures are working, already existing algorithms are working, right? So for that, I have shown you everything scratch by scratch, like step by step, how you can do these things. And yeah, that's about how you go about this. And the final code that I'm having over here is to get the graph comparison, and that's it. We are done with this particular part. Okay. This blue cross is nothing but the actual values. This green line is the scikit-learn model's output, and the black line is our model from scratch. You can see how close it is. Exactly on top of the black line, you're having this green line. So yeah, that's something that you've created, guys, over here, right? So yes, that's the implementation from scratch. That's how you create your own model with the help of linear regression. And yeah, that's about, like, what you have learned in this session. For sure, it might have been a lot of overwhelming for all of you that is present over here. There are still 12 people over here. How is this possible? How is this possible? I don't know. I literally thought there will be no one in this session till now, because trust me, whatever I've explained, is really so much useful for you, especially when you are going to apply for any kind of interviews. They are going to ask you this kind of questions, the internal kind of questions, and going to test you. And the better you will be able to answer this kind of questions, the chances of getting hired will be high with a very good salary. If you are able to explain the internal part of how these things work. After this session, can we get the access of the recording for this? For sure, Prince. I'll be uploading this session on your, on my YouTube channel. That is on Spartificial's YouTube channel. And I'll be sharing this link on our community. Okay. That's what we are going to do. Along with each and everything, the code notebook, the things that I've written on the, paint, and even this PPT, everything will be shared with you. Okay. But guys, just take this moment, guys. Take this moment. You have understood linear regression from scratch. Not a lot of people are aware about this. Trust me when I'm saying this. I have taken a lot of interviews. Not a lot of people are aware about this. And this is exactly what you get asked once you tell your interviewer that, hey, I'm having experience with, let's say, linear regression. I'm very good at linear regression. They're going to ask you the questions like this, how it works internally. And if you are not able to answer like this, code by code, you are missing the chance of, getting the highest kind of salary package that you can think of. Just by answering this kind of things, guys, what I've explained over here. Why did you use a for loop over here? Why did you use this kind of thing over here? All these things will make sense once you just go through this code once more. That's my guarantee, guys. That's my guarantee. And I'm giving you this platform where, let's say, if you're facing any kind of doubts while watching the recording, you can ask me the doubt. How you can ask me the doubt? You can connect with me on our Instagram. That is what, even I'm not sure, to be honest. I'll have to, look for just give me a second. I'm going to give you a link through which you can ask me your doubts. Okay, just give me a second. I'll make sure to answer to each and every one of your doubts. That's my promise, guys. That's my promise. But for that, you need to go through this session once more. Go through the coding part. If any doubt is there, reach out to me. If it's theoretical doubt, if it's coding doubt, anything, let it be anything. I'll make sure to solve it. Okay. But yes, guys, that's something that you have created and you should be really proud of this. Now, the next thing is the roadmap. What I have taught you is just ek boond hai pure sagar ka. You must have heard this kind of line in a lot of workshops, right? I just wanted to say this line, but yeah, this is just one drop of the whole ocean. There are a lot more things you need to learn. And just think the amount of time you will have to spend over here. That's why I told you at the start, by the end of 2024, you will be of that level to get a really good job. That's again one of a commitment. I would not really make a commitment over here because it totally depends on how much amount of work you are putting in. Okay, that's something you need to keep on motivating yourself. And if you are doing it alone, it's becoming so difficult. Trust me, guys, it's becoming so difficult when you do it alone. So just make sure to be part of some kind of community that's working for free of cost. Don't pay anyone to, don't pay even a single penny to anyone. If you're having that kind of guts, and if you're still not that old, you are not having any kind of responsibilities, right? You can take this 1 year challenge. It's now January. By the end of 2024, whatever kind of roadmap I'm giving you, all of this roadmap is coming with some kind of free tutorials that you can use in order to upskill yourself. And trust me, guys, it's going to take a good amount of time to master everything. But yes, if you are committed to this roadmap, it's impossible that you don't get a job. Okay. Let's say if you are done with this roadmap, let's say in June itself, or maybe in August, or whenever you are done with this roadmap. If you are not able to get a job, you reach out to me. You reach out to us on Spartificial. Instagram page I've given. LinkedIn, you can find us on LinkedIn. You can personally find me. Just search about Rohan in this Spartificial profile. You will be able to find me. You personally reach out to me that even after following your roadmap, I was not able to get any kind of job. I'll make sure to make your whatever things that you have created convert in a way that for sure you will be able to get a job. Again, I'm not making any kind of commitment from the Spartificial web. From the Spartificial end, but I am very confident with respect to the roadmap that if you are following this, there is no way that you don't get a job. But trust me, guys, there is one section that I've explained about MLOps. MLOps is the most important part. Okay. But yes, starting with the roadmap, the fundamentals. What are the fundamentals? As you have clearly seen, Python and mathematics is something that you need to know. Is everything in Python you need to know? Everything in mathematics you need to know? No, it's not like that. There is only certain part of Python, certain part of mathematics that you need to know. And once you will be getting access to this part of PPT, you can just click on this particular button. It's going to give you all the resources. Okay, it's going to give you all the resources. Let's say by chance, if this kind of things are not clickable, I'll be attaching a separate piece of document that's going to give you what all kind of things in Python you need to know, what all things in mathematics you need to know. Okay, especially when you are talking about data science job, guys. In data science, not just calculus, you also need to know statistics. Okay, you also need to know statistics. So all of this kind of links I'll be providing in the the reference material, where you don't need to pay anything to anyone. If you are having that guts to do it completely by yourself, take it as a challenge. Okay, from me. Okay, from myself, I'm giving you this challenge that yes, you can do it if you are following this roadmap. All right. So the next step after this fundamentals is the problem statements you need to solve. Okay. What are some of the problem statements you need to solve, guys? So here are the bunch of problem statements that I mentioned. You might be wondering what is all this kind of things, but trust me, guys, the moment you start working on the links, everything that I'm going to give to you, you will be having video tutorials explaining each and everything step by step, just like how I have done it right now. Currently, it might have become something overwhelming for you, right? Some parts might be overwhelming, but do it with certain kind of breaks. Okay. It was just that I really wanted to spend this evening, do something productive and impact some of the lives. Even if it's one life, it's more than enough for me. That was my motto, right? But yes, go through each and every link that is given to you for image classification. What's going to happen in the image classification? Yeah, you're going to learn how to classify different kind of images automatically with the help of machine learning. Same goes for text translation, how you can convert one text to a different language. Then sales prediction, how you can take the data of, let's say, for example, any kind of business and make some kind of predictions in future, that based on this kind of inputs, your sales will increase or decrease. And if it's increasing, then what's the amount? All that kind of thing you can do over here. And let's say if you're running out of the problem statements, this is just few things that I'm telling you guys, okay, to get started with. There are a lot of problem statements that you can go around. But yeah, this is some of the basic problem statements that I'm giving. One is with respect to the computer vision field. One is with respect to the natural language processing, and one is with respect to the classical machine learning algorithm. The one that I have taught you right now is a classical machine learning algorithm. Okay, so one for each of this, I have given some of the example. But for sure, if you want to explore more of this, what you do? You come over here, you go to Chat GPT. Okay, I'm going to just hide this kind of, yeah, and I'm just going to type what are the best, what are the most challenging machine learning engineering projects that I can solve. This is something that I'm going to type. Give me the list of problems. You will see there is a good list that ChatGPT is going to throw. For example, image recognition. Then there is a natural language processing for code generation. How you can, if someone is giving you a statement that, hey, give me a code to train my machine learning model, it should be able to do it for you. It is done with the help of natural language processing. And now, because you are living in the generation of LLMs, doing this kind of thing is just few lines of code. But it's really important for you to understand that if you want to crack any job, you need to understand that how the internal process works, guys. Because just see this in just two lines of code over here. This is the same kind of data that I've already created. It's just the copy paste from the top part. The only one thing you're doing is this part. That's it. In one line of code, you are doing linear regression. In one line of code, you are doing the training part. Dot fit means training, right? And this is the output. In just two lines of code, you are getting the output. But what is the purpose of it if you don't understand how it works? That's not how interviews are going to be impressed. Not at all. You need to know how the basics work, internal part works. That's like, something that you can take my word that in 2024, if you're going to go ahead for any kind of interviews, if you tell them that I'm good with linear regression, they're going to ask every details that you might come up with. Okay, but yes, that's the next step that you're going to do, that solve some different kind of problem statements. Here are the bunch of examples that you can take from the chat GPT, and try to look for the data on the Kaggle itself. Now, what is Kaggle? Let me show it to you. You go to Kaggle. Over here, you can make this kind of notebooks of how you have done over here, but all of these things you will be learning in this process of the roadmap that I've given you. You look forward to the data sets that you're having over here. Okay, this is my data set. Let me just go to the Kaggle again. There is an option of data sets over here, right? You click on this data sets. You will see a lot of data sets over here, a lot of data sets which can help you upskill your game in machine learning. Now, a good part about the Kaggle is that you're also having this kind of competitions. You take part into this kind of competitions, guys. And if you're like, for example, there is detect what is the difference between AI text and a human written text. If you're creating a model over here, you also get some kind of prize money. Okay, there might be some kind of prize money. It must be in the rules. But don't really go after the prize money at the starting part. But surely, once you are good with all this kind of skills, do participate over here and fight for this kind of prize. If you are having even one, it increases your chance to get into any kind of company by literally a lot of amount. If any one competition, you are in top 3. So make sure that you're taking part into this kind of competitions. And yeah, Kaggle is going to be really very helpful for you. And if you're solving a lot of projects over here in terms of competitions, even that is going to show your your interviewer that yes, you are continuously working on this kind of different kind of skill sets. And because you're performing well in the competition, it means you are automatically by default having skills that you're competing with. These are not newbies over here. Okay, guys, the leaderboard over here, they are not newbies. They are people who are having 20 years of experience, 10 years of experience in data science and machine learning. You are competing with this kind of guys. So it's impossible for you to compete with them. But the trick over here is to collaborate with them. You collaborate with this kind of top-notch people who are working really well and taking part in these competitions. You try to collaborate with them. Show them that I'm having this kind of skills. This is the competition, and I'm having a good idea about how LLM works. I can be helpful to you in this way. Send a mail to the top person. See if you're able to collaborate for a next competition with that person. The chances of getting a gold medal increases by a lot of amount. And along with that, you are going to get a lot more experience. Okay, so yeah, that's one of the tips that I'm going to give over here. But yeah, that's with respect to the second thing. Solve as many problem statements as you can in different fields. Because at the start, once you are not having any kind of experience, you can get a job in computer vision. You can get a job in natural language processing, or even a classical machine learning for that matter. Okay, but therefore it's good enough for you to always practice at least 1 or 2 projects in a good way. Okay, you're completing it in a very good way. And yeah, that's what I meant by the problem statements. After this, what are the essential tools that you need to know? Okay, guys, what are some essential tools you need to master? These are the tools. One of them I showed is the scikit-learn. Okay, with the help of scikit-learn, you saw that how with 1 line of code I was able to solve my problem statement with just 1 line of code, or I should say 2 lines of code. 2 important lines of code that replaced this hours of work that we have done. So this is the power of tools. The tools that are most popular whenever you are learning a different type of problem statement, how we are going to solve it, that depends on the type of tool that you're going to use. Okay, so for example, sklearn is very popular for the classical machine learning approaches. TensorFlow and PyTorch is really very popular when you go to computer vision, NLP task. And if you want to automate everything, currently Hugging Face is the leading tool that you can use. Along with that, open AI tools are there, Gemini AI tools are there. All of these kind of tools, you start learning about them. Slowly, you will be able to understand everything. Okay, you just need to be committed and be part of the community. The moment you stop being part of the community, the enthusiasm will go in no time. Okay, you need to be part of community one or the other way, and the best one is Kaggle. People who are having a lot of experience are also taking part in the discussions over there. Okay, if I have to show that to you again, over here you just click there's a discussion part, right? You create any kind of question you want over here: getting started, product feedback, general, competition hosting, whatever it is. You create one kind of, a thread over here. Even the people who are at the top of the kaggle are going to reply to you. That's the power of community. With the community you will be able to, always keep yourself motivated. Okay, again, kaggle is becoming a really important part of the journey when you're learning over here. Okay, after this you can take all of this one step further. It's not compulsory. Okay, this thing is not compulsory, but yes, indeed, if you want a good package, you cannot just stick with this kind of tools. It's nothing. Even a kid can do all these kind of things. But how you integrate these tools with some other kind of tools, like software tools? We are having GitHub, Docker, Cloud, Web, and the databases. How you are able to connect whatever kind of notebook. So the notebook that you have created over here, how you can convert this into a software? How do you do this kind of things? You need to have some kind of knowledge of softwares, right? And therefore, one of the important thing becomes having a knowledge of softwares. Okay, in a company, in a good company, you are not going to work on each and every things. There are some different roles that you will be getting. Let's say, like, one, your role could be just be with respect to software, or else it must be with respect to this kind of tools, or else it might be to, collect the data. Could be anything. But that's only when you get a job position in a very good company. If you are working in a startup, startup in the world of AI is just booming. And literally this kind of ML engineers, and this is what they are looking forward to, this kind of startups. But in the startup, because they're having a low budget, what's going to happen? You are not going to be expected to know only one of these things. And therefore, to take this kind of experience one step further, you need to have at least one project that is able to connect all of these things that you have created into some kind of a software. And the most important is the GitHub part. Okay? Most important is the GitHub part. Okay. Along with that, there are all the other things that I've mentioned over here that you can explore. But yeah, this is to take your game one step further. Okay, but not every company requires this. But surely, why not to give this a chance and at least solve one project that is, literally a production level project that you can convert it into a business, even if it's a personal use. Like how I told you about my case, right? I've created one software that's going to take in my personal data about finance and give me some suggestions of how I can improve it. Just like that, create some kind of project like this. And without knowing this kind of softwares, you cannot do it. The important one is the GitHub. Even if you're not using any kind of softwares, this GitHub is a platform where you can showcase any kind of work that you have created. For example, the work that you created right now, you simply click on file, click on download as IPYNB and store it into your system. Now what you can do, simply you can go ahead and upload it into your GitHub profile and show that this is the kind of work that I have done. GitHub is something that you should be really good with. Okay. So yes, guys, that's how you can take your game one step further. And now comes the BAP of everything. That is MLOps, machine learning operations. Creating this kind of notebooks, the one that you have seen right now with me, is a piece of cake. Okay, it's a piece of cake. Even a small kid can do this by watching this kind of videos. How you're going to differentiate from this kind of bunch of people who are doing this with the people who are at the top, who are knowing this kind of skills like MLOps? What happens in the MLOps? You create this kind of softwares that's going to continuously take new type of data. In any kind of company you will be working, it's not a static data that you'll be working with. Every time, every second, you will be generating hundreds of new data, millions of new data, depending on the the scalability of the company that you're working with. You always will be getting new type of data every second. How you are feeding that to your model, how the model is retraining, how is it again getting the how is it making itself even at a better place, and how you can do it in real time. You can do this only if you know ML ops. And here are some of the tools, only few of the tools that I've written, that even if you know this many tools, you are good to go at the start. Okay, even if you know this many tools, you are good to go. Okay, ML flow is there, data version control, DVC is there, evidently is there. Just go through all the links that I've given. Okay, and try to create one project. It could be literally copy paste of some different people project. It's completely fine. You should be understanding how the project is working and how you are able to explain that to interviewer. If you are able to do it flawlessly, there is no way that they cannot take you in. Okay, but yeah, that's how you do. Start with the fundamentals, go with the problem statement. What are some different problem statements you can solve? Then what are some essential tools you need to know to solve that problem statements? What are software developments you need to understand in order to, like, create some kind of a software out of it? And ML operations, like, have this kind of everything happening in a real time. Data engineering is happening in a real time, training is happening in a real time, testing is happening in real time, everything is happening real time, right? And the last thing is specialization. It's not important, it's only for the people who are already good with all of these steps. It's for you to understand what kind of specialization you want to go in with. It could be computer vision, NLP, data science, whatever it is. It could be with respect to unsupervised machine learning, reinforcement learning, whatever it is. Start specializing into something. Start specializing either the computer vision, where you'll be dealing with images and videos, or maybe NLP that is currently in demand, that is the large language models and everything. Start working on this kind of projects, guys, as soon as possible. And the data science evergreen, you need to know how to get insights from the data and then give some kind of outputs in a way that's going to help business improve. How to cut the cost in the most efficient way is something that you will be letting a company know. And for that cost that you are saving for them, they are paying you this high money. Why are they paying you this high money? Because you are helping them save trillions of dollars. They are giving you this salary of 1 crore per month, or whatever could be a fascinating number for you, right? So that's the kind of thing that you can do with the power of data science. So this is the whole roadmap that you can follow. And the only one thing is, guys, indeed, this kind of thing is challenging. And with the help of resources, obviously you will have always some kind of resources to look forward to. But until you start creating the projects and you don't upload it into the GitHub, if you don't upload it into your LinkedIn profile, that, hey guys, you know what, I have done this kind of things, the chances of you getting hired will be very less as compared to the people who are even doing very small amount of work. Let's say even this amount of work they are doing and approaching to some company, their chances of getting hired will be very high as compared to you, even after doing all of these things, but not updating your profile on GitHub, not updating your profile on your LinkedIn. That's something, take me when I'm saying this, okay? Take this from me. It's really important that you start showing up your progress on the GitHub. It can start with as simple thing as you can think of, but slowly with time, day by day, month by month, you will see that the improvement that you are doing is a lot. And that's why I'm not saying it's a 1 day task, 1 month task. You will take good enough of time. You might take even more than 1 year of time. But yes, this is the roadmap that you need to follow. And especially in 2024, this is the tool that you need to learn, ML Ops. If you learn this tool, the chances of you getting hired will again increase by a lot of amount, because right now all of these things can be done with the help of large language models very simply. One line of code you need to write, but how you manage this kind of code, how you manage this kind of type of environment in real time, how you do this kind of things is going to be dependent on how good you are with the ML ops. But you cannot directly jump onto the ML ops before trying all of these things, because all of this thing is going to help you to understand, okay, yeah, this is what I have done, and now how can I do it in a much more better way in real time, is what ML ops comes into the picture. So you go step by step. Okay, don't directly jump into the ML ops, you will just be confused. Okay, but yeah, and yes, once you are done with this, if you're having enough time by December, you can also do some more projects. Let's say by doing different kind of problem statements, you are loving to solve problems with respect to computer vision, like that is images, videos, right? You go into the computer vision. Okay, you can also go for the natural language processing if you like to create something that is with respect to the human text that machines are able to understand, and do something with respect to that. Data science is, again, I've explained much with respect to that, so I'll not repeat that. But yes, this is a complete roadmap, guys. Complete roadmap that if you follow step by step, it may take, let's say, one complete 1 month to understand the fundamentals, 3 months to solve problem statements. One at the same time you are solving the problem statements, obviously you are using some certain kind of tools. So all of this kind of tools, start by one tool. Start by one tool, scikit-learn, TensorFlow, PyTorch, Hugging Face. Go step by step, experience all of these different kind of tools, and get this ability to explain your project to someone. If you are able to do that, you are doing really very good. Okay, after that, if you really want to, work in a much more better position, you do this. It's optional, completely optional. When I had started my journey, I didn't know anything of this, including GitHub. I was not even aware about what was GitHub. Okay, but yeah, soon you will start working with some kind of companies, you will understand the power of this. But let's, you can start even with the internship. With that internship also, you can learn all of this kind of things at the same time while doing the internship. Isn't it just great? So yeah, but start doing something. Don't hold yourself. Keep on improving day by day. Every day if you do something new is going to contribute into your this challenge of 2024, that you are going to transform yourself from nothing to literally a very good kind of package that you can get. Right? But yeah, these steps are important. And in any time of this roadmap, if you're facing any kind of difficulties, I have told you how you can approach me. Simply approach me. I'll be giving you solution to any kind of problem that you will be facing, including if you are not getting a job, you are following all of this kind of strategies. I'll tell you what is the wrong thing you are doing, how you can fix it. I won't charge a single thing from you. But yes, you need to at least go through, skip this part, let's say for now, but at least this first three things you need to go through. These first three things are most important. Before you reach out to me, these first three things should be done. Okay. At least one problem statement from the CV, that is the computer vision, one from the NLP, one from the classical machine learning, and at least one competition. Even if you're not performing well in the competition, but take at least one part in the competition and see how you're able to perform. Once these three things are done, guys, you reach out to me. I'll tell you what you should be doing next. Okay. But yes, this is the complete roadmap, guys. This is the complete roadmap. It's already 10:49. I did not really imagine I'll be going more than 3 hours, but yeah, that's how it works, right? But yeah, let me just go through the final thing very quickly. This is not that important at all. Okay, what are the programs at Spartificial? This is not really that important as of now. But let's say if you are someone who is looking to get started with, you are having no idea at all, and if you want to understand that how you can fuse this AI thing with the help of astronomy, then here we are coming up with the training programs. We already always run this kind of batches with some different kind of project. Okay, how is this project working? We are giving you a problem statement that you will be solving, starting from Python, going all the way up to the data science, the level that you have to reach in that project. For example, the artificial intelligence for lunar exploration. What does this happen? Like, what do we teach over here? I am the prime, I am the main instructor in both of these batches. Both of these batches, I am the primary instructor. Okay, so if you are liking the way that I'm explaining, this is what you're going to get. Okay, but yes, it's going to be 10 weeks long program. Both of them are 10 weeks long program. Okay, and what's going to happen over here, guys? You're going to start from the basics of Python. From that Python, how one step closer every week you go to the problem statement that you are defining at the starting of your training program. So yeah, over here, what you're going to make is the image segmentation kind of thing. Okay, so what you have seen over here, something like this, but for the lunar data. On the lunar surface, how you can identify there are rocks present, small rocks present, where is the sky, where is the end of the, the vision, where is the horizon, all these kind of things your model will be able to segment. It's eventually going to, we are not going to tell you that, how you are going to integrate these things into your rover, rather give you a skill through which you can start doing at least this kind of thing. Okay, in this kind of training programs, what you do is you get up to this level, guys. This thing, first three steps are done with at least one problem statement. Okay, with at least one problem statement over here. This is with respect to computer vision domain. Just like that, over here that we are having is astronomical data science. Over here we cover a lot of different things, starting from basics of Python, then image processing. If you are someone who is highly interested to work in image processing part, okay, how you can find out the presence of black hole, or the, what are the chances of presence of the black hole in that way. And you are able to do this with the help of only few skills. is something that we teach. And at the end of the training program, we teach you machine learning, deep learning, including computer vision. Okay, so that's what we do over here. And both of them are going to run for 10 weeks long. And specifically for the AI for LR batch, that is the artificial intelligence for lunar exploration, we are also going to learn one more thing, that is how you can do a combination of ML ops, and this one step further, how you can at least deploy, okay, how you can deploy your models. That's again one thing that you will be learning in this AI for LR batch. But yes, guys, this is what we are providing. If any one of you are clueless of what to do, even after telling you all these things, if you want a step-by-step guidance that I'm going to provide it to you every week by week, this is what you should do. Okay, that's something that I would really like to tell. And over here, you can clearly see that after your training program is done, you are also going to get internship. Are this paid internship? No, they are not paid internship. But by the end of the internship, you will be of a level where you can start doing this kind of projects by yourself, and within just next 1 month, you will be of that position that I'm talking about over here, this roadmap. Maybe 1 or 2 more months. But yeah, by the end of December, you will be having more chance to complete this roadmap if you are continuously in touch with me or with anyone in Spartificial for that matter, right? So, yeah, but again, this is not some kind of a promise that we are making. It completely depends on your dedication, guys. Okay, the more dedication you will show, the better results you will be getting. Okay, that's something that you need to know. There is no promises that I'm doing over here. Okay, especially on the behalf of Spartificial. When it comes to on my personal level, for sure, I'm telling you, I'll make sure to get you to that level where you can get a very good job if you follow this roadmap. And to get you started with the roadmap where you're completely clueless, even after giving you all this kind of links, it's completely fine. I understand. I have been through that. I have taken this kind of courses in past because one point of time I was clueless about this. I am from the astronomy background. Just think about it. I am from the astronomy background, astrophysics background. How was I able to do this? It's only because I was clueless. I was not knowing anything in this kind of domain. It's just because of this kind of courses I was able to learn it. So yeah, if you're completely clueless, like how I was once upon a time, there is nothing wrong with that. But yeah, for that you will have to provide some kind of charge that we charge over here. For example, for this 10 weeks of course plus 2 months of internship, the charge is 4,990. And for the AI for other batch, it's again 4,990. But over here, you're going to get some better opportunities in order to upskill yourself, not in terms of getting a job. That's one thing I would like to make a clarification over here. But yes, guys, that's something that you will be doing. You will be working with different bunch of instructors. This is me. What's up, bro? But yeah, that's what we are going to do. All right. And lastly, guys, lastly, almost 11. Did we just take this workshop for 4 hours? That's insane. But yes, thank you so much, guys. For how many people are staying right now? Let me check. There are 11 minus 2 is what? Is it 7? No. Is it 9? Oh, it's 9, right? Yes. So 9 people are there currently. Just think about it, guys. The kind of knowledge that you got over here in 4 hours, it's very hard to get nowadays in one place. But you have got this. Now it completely depends up to you how you want to upskill yourself. What is the process you want to follow? I have also given my contact, right? You can always reach out to me in any kind of problem you face. Let it be financially, let it be anything. I'll try my best to help you in the best possible way that I can help you at that time. And yeah, you can get started with your career, right? So yeah, that's something that we are providing over here. Thank you so much to stay till now, because I would have completely been bored on Saturday evening. But yes, and I hope that I've provided some kind of valuable, valuable things in your this 4 hours. And all the best for your journey, guys. I wish you all the very best. Everyone who is watching the recording over here till now, also to each and every one of you as well. I wish you all the best. I hope that by the end of 2024, if you are following this roadmap, you are having a very better opportunities right in front of you, and you can land a very good job. All right, guys, all the very best to you. Yeah, that's the end of this particular workshop. I'll be taking some of the doubts. Let me just look into it. Yes, guys, for those who wants to leave the session, you are free to leave. Thank you so much once again to stay till here. Okay. And you are going to thank me, not directly, but indirectly. You will see that, there was some person who was teaching me this kind of thing on a random Saturday evening, and that helped me so much. You're going to thank me if you're going to follow this roadmap.